Somewhere around 12,000 years ago, the world you would have recognized simply stopped existing. The glaciers that had covered entire continents for over 100,000 years began pulling back. Sea levels rose by hundreds of feet, swallowing coastlines whole. Animals that had roamed the earth since before humans existed, mammoths, giant sloths, saber-toothed cats, vanished within a few thousand years. And somewhere in the middle of all this chaos, human beings did something no one fully expected. They stopped wandering and started building. Now, here's the question that's been quietly haunting archaeologists, geologists, and a whole lot of internet documentary makers for the last few decades. Was this just climate change doing what climate change does? Slow, predictable, explainable by orbital cycles and melting ice? Or was something else going on? Something that keeps happening. Something with a rhythm to it. Some researchers, and a much larger crowd of amateur theorists, have pointed to a strange pattern. Major disruptions to life on Earth seem to cluster around roughly 12,000-year intervals. Not exactly, not like clockwork, but close enough that people started asking uncomfortable questions. Is civilization, or the possibility of civilization, reset periodically by forces bigger than us? And if so, are we due for another one? If you're listening to this while trying to fall asleep, that's exactly what these episodes are for. So go ahead. Let your eyes close, let your mind drift. And if you want, tell me in the comments where you're listening from and what time it is right now for you. I love reading these. Sydney at sunrise, London at midnight, somewhere in Texas at 3 a.m, because the mind just won't quiet down. It's strangely comforting knowing people all over the world are drifting off to the same voice at completely different hours. And if you enjoy this, the kindest thing you can do is follow the show on Spotify and leave a 5-star review. It genuinely helps more than you'd think, and the link is right there in the description whenever you're ready. Now, back to 12,000 years ago, because this is where things get genuinely strange, not because of dramatic pseudo-history claims, though we'll get into those, but because of what the actual evidence shows. Somewhere in this window, humans built the oldest known monumental structure on Earth. Not crude piles of stone, carved pillars, deliberate engineering, symbolic art. This shouldn't have been possible according to the old timeline of human development. Complex societies weren't supposed to exist yet. Agriculture hadn't been invented. Writing was thousands of years away. And yet, there it is, buried in the hills of southeastern Turkey, quietly rewriting what we thought we knew about who we were at that point in history. At the same time, something happened to the climate that scientists still argue about today. A sudden, brutal return to Ice Age conditions right when the world seemed to be warming. It lasted over 1,000 years, and it may have reshaped human society more than almost any single event before it. So which is it? Was 12,000 years ago simply a difficult transition? One climate shift among many that humanity muscled through the way we always have? Or was it something closer to a reset, a collapse serious enough that it erased whatever came before, leaving only fragments, myths, and a handful of stone pillars as evidence that something had been lost? The honest answer is, we don't fully know. And that uncertainty is exactly what makes this period so fascinating. Because buried somewhere between hard archaeological evidence and speculative theory is a genuine mystery about how fragile or how resilient human civilization has always been. Let's start at the beginning with where this idea of a 12,000-year cycle actually came from. So, where does this number actually come from? 12,000 years. Say it enough times, and it starts to sound like a fact, something measured, something proven, like the half-life of a radioactive isotope or the orbital period of a planet. But here's the first thing worth understanding before we go any further. Nobody discovered a 12,000-year cycle sitting in the geological record. waiting to be found. Nobody drilled an ice core and pulled out a repeating signal that said, right here, right here, right here, precisely 12,000 years apart. That's not how this number entered the conversation at all. What actually happened is much simpler, and honestly, much more human. Around 12,000 years ago, give or take a few centuries depending on which dating method you trust, the last ice age ended. Glaciers that had locked up a huge percentage of the planet's water for tens of thousands of years began retreating. Sea levels rose, ecosystems transformed, and not long after, in the archaeological blink of an eye, human beings began farming, building, and eventually writing things down. That transition from Ice Age hunter-gatherers to the first farming villages is real. It's documented. It's one of the best supported turning points in the entire human story. The number 12,000 comes from that transition, not from a repeating pattern from a single event. So how did a single event turn into a supposed cycle? This is where things get interesting, and where we have to be honest about the difference between evidence and interpretation, starting in the 20th century and picking up serious momentum in the decades since. A number of writers noticed something that seemed, at first glance, genuinely strange. Around the world, in places that had no contact with each other, ancient myths described a great flood, a great fire, a darkening of the sun, some kind of catastrophic ending to a previous world. Mesopotamian tablets, biblical scripture, Aboriginal Australian oral traditions, Andean legends, stories passed down in Ireland, in China, in the mountains of Mexico. Different cultures, different continents, different centuries of origin, and yet a strikingly similar shape to the story. Something terrible happened. The old world ended, and the survivors had to start again. To some researchers, this was simply what you'd expect from human societies living through the genuine climate chaos at the end of the Ice Age. Real floods, real coastal flooding, real environmental upheaval, remembered and reshaped into myth over thousands of years of retelling. We'll come back to this idea later, because it deserves a careful look on its own. But to another group of writers, the similarity suggested something bigger. What if these stories weren't just describing local disasters? What if they were fragments of memory from a single shared global catastrophe? And what if that catastrophe wasn't a one-time event, but part of a repeating pattern written into the deep structure of the Earth itself? This is roughly where the 12,000-year collapse theory, as most people encounter it today, actually takes shape. Not in a peer-reviewed journal, not in a geology department, but in a lineage of alternative history writing that stretches back decades and has only grown louder with the arrival of the internet. You've probably heard some of the names, even if you can't place them exactly. Writers who proposed that an advanced, technologically sophisticated civilization existed before the end of the Ice Age, one that was wiped out by some global cataclysm, a comet impact, a pole shift, a solar event, take your pick, and that the survivors scattered across the globe, carrying fragments of lost knowledge with them. In this version of the story, structures like the pyramids of Egypt, or the ruins scattered across South America, aren't the beginning of civilization. They're the leftover echoes of something that came before, something erased so thoroughly that only stone remembers it now. It's a compelling story, it really is. There's something deeply satisfying about the idea that we're not as new as we think, that somewhere beneath the official version of history there's a deeper, older, more mysterious version waiting to be uncovered. And to be fair, this kind of thinking picked up genuine momentum for a reason we'll spend an entire section on later. Because in the 1990s, archaeologists really did find something that shouldn't have existed according to the standard timeline. A massive, deliberately carved stone monument in southeastern Turkey, built thousands of years earlier than anyone thought organised construction was possible. We'll walk through that discovery properly soon, because it deserves the attention. But its existence became, for many alternative history writers, a kind of proof of concept. See, they said, the old timeline was wrong, which means maybe the rest of the old timeline is wrong too. Maybe there really was something before, something bigger, something lost. From there, the theory spread the way theories tend to spread now. Documentaries, book series that sold in the millions, long-form videos with dramatic narration and slow zooms into satellite images of the ocean floor, podcasts, forums, late-night conversations that start with, "Have you ever heard of?" and end 2 hours later with someone questioning everything they learned in school. None of this makes the idea automatically wrong, and we're not here to mock anyone who finds it fascinating. Curiosity about our own deep past is one of the most human impulses there is, but it does mean we should be careful about where the number 12,000 is actually coming from when we hear it. Not from a documented, repeating geological cycle, from the end of one ice age dressed up over the decades into the idea of a pattern. Now, here's where we need to pause and draw a distinction that gets blurred constantly in this conversation, and it's an important one. The age of civilization and the age of humanity are not the same thing, and confusing them is where a lot of the mystery and a lot of the misunderstanding actually comes from. Modern humans, biologically speaking, have existed for somewhere in the range of 300,000 years. That's not a controversial number. It comes from fossil evidence, from genetic studies, from the kind of research that gets cross-checked by labs on different continents, using completely different methods, and still arrives at roughly the same answer. 300,000 years of humans who looked like us, whose brains worked essentially like ours do now, who were capable, in principle, of the same creativity, the same problem-solving, the same capacity for connection and memory that you have right now, listening to this in the dark. Civilization, meanwhile, in the specific sense of large settled populations, agriculture, cities, writing, is almost absurdly young by comparison. The oldest confirmed cities appear somewhere around 6,000 years ago. Agriculture stretches back further, maybe 10 to 12,000 years in its earliest forms. Even Göbekli Tepe, that impossible monument we'll spend real time on later, only pushes organized construction back to around 11 or 12,000 years ago. Compare that to 300,000 years of human existence, and you start to see the actual shape of the mystery. Not why did an advanced global civilization vanish and reset every 12 millennia, but why did it take our species so unbelievably long to start building anything at all? That question, on its own, without any need for lost continents or ancient astronauts, is genuinely strange enough to keep researchers up at night. What were humans doing for 290,000 years before the first town appeared? Why then? Why there? Why did it take an ice age ending, glaciers retreating, sea levels rising, to finally push a handful of scattered groups toward permanent settlement, after hundreds of thousands of years of successfully not needing one? So this is really where our investigation has to begin. Not with the assumption that a great cycle exists, and not with the dismissal that nothing strange happened at all. Somewhere in the middle, in the actual evidence, in the ice cores and the sediment layers, and the flooded coastlines, and the impossible stone pillars buried under a hill in Turkey, there's a real story. A story about a climate crisis far stranger than most people realize. A story about coastlines that vanished under rising water, taking with them anything that might have been built along the shore. A story about myths that may or may not be memories. And a story about whether the idea of civilization being periodically wiped clean is something the evidence actually supports, or something we've built, understandably, out of our own fascination with endings. Because before we can ask whether we're overdue for the next collapse, we need to understand carefully and honestly what happened the last time the world seemed to end. But if the number itself isn't a proven cycle, That doesn't mean Earth is chaotic in the sense of being completely random. Far from it. The planet has clocks, big ones, small ones. Clocks in the oceans, clocks in the atmosphere, clocks in the slow movement of continents, and clocks in the geometry of Earth's path around the Sun. The question is not whether natural cycles exist. They absolutely do. The question is whether any of them work like a countdown timer for civilization. And the answer, at least based on everything we currently know, is no. Earth's most important long-term climate rhythms begin in space. Not with comets, not with mysterious energy bursts from the centre of the galaxy, but with the slightly complicated way our planet moves around the Sun. Earth doesn't travel in a perfectly fixed circle. Its orbit changes shape very gradually over time. The tilt of its axis, which gives us the seasons, slowly shifts too. And the direction the axis points, like the wobble of a spinning top, traces out a long, slow circle through the sky. These changes are tiny from one human lifetime to the next. You would never notice them by standing outside on a summer afternoon. But over tens of thousands of years, they alter how sunlight falls across the planet, especially at high northern latitudes where the difference between a cool summer and a slightly warmer one can determine whether winter snow melts away or survives long enough to become next year's ice. This is the basic machinery behind the great glacial cycles of the last few million years. Ice sheets expand, ice sheets retreat, sea levels fall by hundreds of feet, then rise again. Deserts shift, forests spread and shrink. Entire regions become habitable, then dry out, then become habitable again. Scientists call these orbital rhythms Milankovitch cycles, after the Serbian mathematician Milutin Milankovic, who spent much of the early 20th century working out how changes in Earth's orbit might influence climate. And weirdly enough, he was doing some of this work while under house arrest during World War I, which is a pretty dramatic setting for equations about summer sunlight from 100,000 years ago. But the central idea held up. Later, when researchers drilled deep into ocean sediments and Antarctic ice, they found evidence that Earth's climate had indeed moved in patterns broadly connected to these orbital changes. There are three main parts to it. First, eccentricity. That's the changing shape of Earth's orbit, moving very slowly from more circular to slightly more oval and back again, on cycles roughly around 100,000 years long. Second, obliquity, the changing tilt of Earth's axis, which moves on a rhythm of about 41,000 years. More tilt means more extreme seasons, less tilt means milder ones. And then there is precession, the wobble, which changes the timing of the seasons relative to where Earth is in its orbit. That operates mostly on timescales of around 19,000 to 23,000 years. Now, if you're looking for a 12,000-year pattern, you might already see the temptation here. 23,000 years cut it roughly in half, gives you something in the neighbourhood of 11 or 12,000. And this is one reason these claims can sound more scientific than they really are. There are real cycles in the background. There are real numbers. And some of those numbers are close enough to 12,000 years that if you want to find a connection, you can make one feel plausible. But close is not the same as connected. Precession does not produce a global reset every half cycle. It changes the distribution of sunlight between seasons and hemispheres. Its effects depend on other conditions already in place. How much ice exists, how reflective the planet's surface is, how much carbon dioxide is in the atmosphere, what the oceans are doing, whether large ice sheets are stable or already close to melting. Earth is not a simple machine where you turn one gear and get one predictable result. Think of it less like an alarm clock and more like a very large, very sensitive thermostat in an old house. The furnace comes on, the rooms warm unevenly, a window rattles open somewhere upstairs. Wind pushes cold air through the basement. The thermostat reacts late. Then someone throws another blanket over it. The system has rhythms, absolutely. But predicting exactly what will happen in every room, at every moment, is much harder than knowing the furnace has a cycle. This is why glacial periods don't arrive like trains on a timetable. The broad pattern is real. Over the last million years especially, large ice ages have tended to recur at intervals around 100,000 years. But the timing is not perfectly regular. The severity isn't identical. The transitions are often messy, and the mechanism isn't just orbital forcing acting alone. It is orbital forcing amplified by feedback loops inside Earth's climate system. A little more summer sunshine can melt a little more ice. Less ice means darker land and ocean are exposed. Dark surfaces absorb more heat than bright ice. More warming leads to more melting. Meanwhile, warming oceans and changing ecosystems can alter greenhouse gas levels. Carbon dioxide rises, methane rises, the warming grows stronger. A small orbital nudge can become a planetary transformation, not because the nudge was enormous, but because the climate system responds to itself. And then, sometimes, the opposite happens. Cooling spreads, snow lasts longer, ice reflects more sunlight, the planet slips deeper into an ice age. The same world, the same sun, the same basic physics, but moving through a chain reaction so slow that generations of humans could be born, grow old and die without realizing the climate was changing around them. That's a real Earth clock. It is powerful enough to redraw coastlines and reshape the map of human possibility. But it is not a clock that says civilization ends every 12,000 years. There are other rhythms too. The oceans have their own pulses. In the Pacific, El Niño and La Niña rearrange rainfall and temperature over periods of a few years. They can bring drought to one continent and floods to another. They can alter harvests, fisheries, storms, and disease patterns. Longer ocean changes, operating over decades or centuries, can shift weather in ways that are still difficult to untangle completely. The sun has cycles as well. The most familiar is the roughly 11-year rise and fall in sunspot activity. It can influence space weather, radio signals, and, in subtle ways, the upper atmosphere. But it does not appear to provide the kind of energy needed to repeatedly overturn Earth's climate or erase human societies on schedule. Solar activity matters. It just doesn't behave like a cosmic demolition switch. Volcanoes can cool the planet temporarily by throwing sulfur-rich particles high into the atmosphere, where they reflect sunlight back into space. A truly massive eruption can damage harvests across wide regions. Asteroid impacts can be devastating too, though large impacts are rare and do not arrive with the dependable rhythm of a calendar. Earthquakes, tsunamis, droughts, floods, pandemics, wildfires. All of them can be catastrophic. All of them have shaped history. But none of them line up into a recognized global 12,000-year destruction cycle. And this brings us to a problem that isn't really geological at all. It's human. Our brains are pattern-making machines. They have to be spotting patterns kept our ancestors alive. If birds suddenly disappear from a valley, maybe a predator is nearby. If dark clouds gather from the same direction every afternoon, maybe it's time to get shelter ready. If a certain plant makes people sick, remember it. Tell the children, don't eat it. The cost of seeing a pattern that isn't real was usually small. The cost of missing a real pattern could be fatal. So we became very good at connecting dots, even when the dots are scattered, incomplete, and separated by thousands of years. Look at enough dates from enough ancient disasters, and you can almost always find a rhythm. A flood here, a city abandoned there, an empire falling centuries later, a volcanic eruption in another part of the world. Round the dates off slightly, because ancient dating always carries uncertainty. Choose the events that fit, ignore the long stretches when nothing comparable happened. And before long a pattern begins to emerge. This isn't stupidity. It's a normal feature of human perception. Researchers sometimes call it apophenia, the tendency to see meaningful connections in random or uncertain information. You know it when you see a face in the grain of wood or an animal shape in a cloud. In history, it is more seductive because the pattern comes with names, ruins, legends, and dates that feel important. The problem gets even worse in deep time because our records are wildly incomplete. For most of human existence, nobody was writing anything down. No census records, no newspaper archives, no precise list of drought years, crop failures, migrations, small wars or villages quietly abandoned because a river changed course. Archaeology gives us fragments, a layer of ash, a broken wall, a cemetery, pollen preserved in mud, a sudden drop in tree growth recorded in rings of ancient wood. These fragments are incredibly valuable. They can tell us astonishing things. But they are not a complete diary of the planet. Imagine trying to reconstruct the history of a family from 3 photographs, a grocery receipt, and a single sentence written on the back of an envelope. You might correctly identify a wedding, a move, a hard winter, but you would also be vulnerable to inventing connections that were never there. Now expand that problem across every continent, across 12,000 years, while coastlines have drowned, forests have grown over settlements, and most organic materials have decayed into nothing. That is the challenge. A genuine, repeating cycle should leave a clear fingerprint, not just one famous catastrophe near the end of the Ice Age, followed by a collection of unrelated disasters loosely arranged around similar numbers. It should appear repeatedly in independent records. Ice cores, lake sediments, ocean sediments, tree rings where they exist, cave deposits, archaeological layers from widely separated regions. And it should have a mechanism capable of producing the same kind of global effect again and again. So far, no such fingerprint has been found for a civilization-destroying event every 12,000 years. That doesn't mean the past was safe. It definitely wasn't. The end of the last ice age was one of the most unstable periods humans had ever lived through. Temperatures jumped, rain belts shifted, huge ice sheets collapsed. Sea levels rose so far and so fast in geological terms that entire landscapes where people had once hunted and camped vanished beneath the ocean. But unstable is not the same as periodic. Catastrophic is not the same as scheduled. And maybe that distinction is more unsettling than the countdown story. A fixed cycle would at least give us the comfort of a date, a pattern, a warning written into the machinery of the universe. Real history offers something less tidy. Earth has rhythms, but they overlap. They interfere with each other. They build slowly, then sometimes change suddenly. Human societies respond in different ways depending on where they live, what they grow, who they trade with, and how much flexibility they have left when the pressure begins. So if civilization has no 12,000-year expiration date, what exactly did the world look like 12,000 years ago, when this number first became so important? To answer that, we have to return to a planet still holding the last grip of the Ice Age. A world with coastlines far beyond the shores we know today. A world full of mammoths, giant deer, and hunters following rivers across land that is now ocean floor. A world on the edge of a transformation so vast that, for the people living through it, it may have felt very much like the end of everything. At the end of the last ice age, around 12,500 years ago, the planet was familiar enough to recognize, but strange enough to feel like another world. Not an empty world, not a primitive waiting room before civilization arrived. It was a crowded, changing, highly intelligent human world, lived in by people who knew their landscapes with an intimacy most of us can barely imagine. The ice sheets were still enormous. In North America, the Laurentide ice sheet covered much of what is now Canada and stretched south into parts of the northern United States. In Europe, ice covered Scandinavia, much of the British Isles, and high mountain regions farther south. These were not just patches of snow on distant peaks. They were continent-sized masses of ice in places more than a mile thick, pressing down on the land beneath them with unimaginable weight. And because so much water was locked inside those ice sheets, the oceans were lower. At the height of the Ice Age, sea level had been more than 100 metres lower than it is today. The coastlines on a modern map simply did not exist yet. Britain was not an island. You could have walked from what is now England across a broad plain toward mainland Europe. That landscape, often called Doggerland, included rivers, marshes, grasslands, woods and herds of animals. Today it lies beneath the cold, shallow waters of the North Sea, its old river valleys buried under sediment. Farther east, Southeast Asia looked completely different. The islands of Sumatra, Java and Borneo were connected to the Asian mainland by a vast exposed plain known as Sunderland. In the north, Siberia and Alaska were joined by Beringia, a broad, cold but surprisingly productive region where people and animals could move between Asia and North America. The world had more land, different land that is now invisible to us except in sonar maps, sediment cores, and the occasional ancient tool brought up from the sea floor. This matters because much of the human story from the end of the Ice Age took place in places that no longer exist above water. When people ask why we have not found more evidence of ancient settlements, the answer is sometimes very simple. We may be looking in the wrong place. The old coastlines are underwater. But the land that remained above sea level was no gentle paradise. It was a patchwork of extremes. South of the ice sheets stretched wide-open grasslands, shrublands and tundra-like plains. Some areas were dry and windy, others were crossed by rivers swollen with glacial meltwater. Forests were returning in some regions as temperatures rose, while elsewhere cold conditions still held on. The climate was warming overall, but not smoothly. It was lurching, pausing, shifting rainfall belts, changing seasons, and remaking habitats within the span of human lives. And moving through this world were animals that now seem almost mythical. Mammoths wandered northern grasslands, mastodons lived in the woodlands of North America. Giant deer with antlers wider than a person stood in European forests and open country. Woolly rhinoceroses, steppe bison, wild horses, reindeer, cave lions, dire wolves, camels, giant ground sloths and enormous beavers occupied different corners of the planet. Not every place had every animal, of course. The Ice Age world was diverse and its ecosystems were local. But almost everywhere, humans lived among creatures larger, stranger, and more dangerous than the animals most of us encounter today. To survive here required far more than simple toughness. It required knowledge, detailed, inherited, constantly updated knowledge. A hunting community needed to know where reindeer would cross a river in spring, which valley held shelter during winter winds, which plants became edible after roasting, soaking or grinding, which stones made sharp blades, where to find ochre for pigments. How to preserve meat, how to make clothing that could keep a child alive through a long, cold night, how to read tracks in snow, mud, dust and grass, how to notice when the weather was changing before the storm arrived, and they had to pass that knowledge on. This is one reason the old image of Ice Age people as isolated, barely surviving individuals is so misleading. They lived in small communities, yes, but small does not mean simple. A group of a few dozen people could carry generations of practical expertise, social rules, stories, rituals, family histories, and maps of the landscape stored in memory rather than written on paper. They also had relationships beyond their immediate camp. Archaeologists find stone tools made from materials carried over long distances. Shells from coastlines appear far inland, amber, obsidian, pigments, animal teeth, and carefully shaped objects moved from group to group across hundreds of kilometres. Sometimes we cannot say exactly whether an object travelled through direct trade, seasonal movement, gift exchange, marriage networks, or several hands over many years. But the larger picture is clear. Late Ice Age people were connected. A person living in one valley might never meet someone from a distant coast. But an ornament, a tool style, a story, or a marriage partner could travel between them. These networks mattered. In a dangerous and unpredictable world, connections were insurance. If one region failed, relatives or allies elsewhere might know another route, another resource, another place to go. And these people did not spend every waking hour struggling for calories. Their lives included beauty, symbolism, and memory. By this time, humans had already been making art for tens of thousands of years. Deep inside caves in France and Spain, artists painted horses, bison, deer, lions, and abstract signs with astonishing skill. In other places, people carved animals from bone, ivory, antler, and stone. They made beads. They buried some of their dead with ornaments, tools, pigments, and objects that seem to have carried special meaning. We should be cautious about claiming to know exactly what these images meant. A painted bison is not a written sentence. A grave is not a direct explanation of a person's beliefs. But the evidence tells us something important anyway. These were people capable of imagination, tradition, ritual, and shared symbols. They did not merely inhabit the landscape, they interpreted it. Picture a family camp near the edge of a river plain, someone repairing a spear point, someone scraping a hide, children learning which bones can be broken for marrow, an older person telling a story that explains why an animal behaves a certain way, where a river becomes dangerous, or which ancestors first crossed a mountain pass, smoke drifting from a hearth, food being shared according to rules everyone understands, a necklace passed down through generations, a song that helps preserve a memory of a distant place. None of this leaves much trace after 12,000 years. Wood rots, leather disappears, baskets vanish, spoken language evaporates. Even campsites can be scattered by floods, burrowing animals, roots, frost, and later human activity. What survives is usually the hard, durable fraction: stone, bone, charcoal, pigments, fragments of shell. So the archaeological record can make ancient life look sparse. But sparse evidence is not evidence of sparse lives. In fact, the end of the Ice Age was a period when human communities were experimenting, adapting, and spreading into newly available landscapes. As the climate warmed after the coldest phase of the last glaciation, glaciers retreated. Plants shifted northward and uphill. Herd animals changed their migration routes. Lakes formed where ice had blocked rivers. Forests began advancing into grasslands. For some groups, new opportunities opened. For others, familiar hunting grounds became less reliable. Imagine knowing a landscape your grandparents had known, only to watch it slowly become another place. The river changes course. The open plain becomes woodland. The animals your community depended on grow scarce. A coast that once lay days away moves farther and farther from camp as the sea rises. You do not know the words greenhouse gas feedback or meltwater pulse. But you know the world is changing, and it was changing fast by geological standards. During the warming phase before the Younger Dryas, often called the Bowling-Uller-Road interval. Temperatures across much of the northern hemisphere rose dramatically. Ice sheets began to lose mass. Meltwater poured into rivers and oceans. Sea level rose in bursts, though the exact pace differed across regions and remains an active area of research. Ecosystems reorganized. Some animals expanded into new territory. Others retreated or disappeared from places where they had long been common. For humans, there was no single ice age ending. There were thousands of local endings. A wetland drying out, a forest appearing where hunters once watched herds across open ground, a shoreline swallowed by the sea, a migration route becoming blocked by water, ice, or dense woodland. But after centuries of warming, something unexpected was about to happen. The planet, which seemed to be leaving the Ice Age behind, would suddenly swing back toward cold. And for communities already living through a world in motion, the Younger Dryas would bring another hard lesson. Climate does not always change gradually enough for human memory to keep up. Around 12,900 years ago, the warming stopped. Not everywhere in exactly the same way, not on the same day, or even in the same decade. Climate is too large, too complicated, too unevenly distributed for that. But across much of the northern hemisphere, especially around the North Atlantic, the trend reversed with astonishing speed. The world had been thawing. Ice sheets were retreating. Forests were spreading into territories that had been cold grassland and tundra. Rivers were changing. Animals and people were shifting with them. Then, suddenly, by geological standards, cold returned. This interval is called the Younger Dryas, named after a small Arctic flower, Dryas octopetala. It grows in cold, open environments. When pollen from this plant began appearing again in sediments across parts of northern Europe, it told archaeologists and geologists that conditions once favourable to cold-adapted plants had returned. It was as if the Ice Age, on its way out, had looked back over its shoulder and decided to stay a little longer. The Younger Dryas lasted roughly from 12,900 to 11,700 years ago. That is more than 1,000 years, long enough for children born during its beginning to have grandchildren who knew no other climate. But the beginning was what made it so remarkable. In Greenland ice cores, long cylinders drilled deep into the ice sheet. Chemical signals suggest that temperatures changed dramatically within only a few decades. Some estimates indicate that Greenland may have cooled by around 10 degrees Celsius or more. In a human lifetime, perhaps even within the memory of one generation, a relatively mild world became much colder. That does not mean every part of Earth froze at once. Greenland is not the whole planet. The strongest cooling was concentrated around the North Atlantic, and conditions varied enormously from region to region. Some places became colder and drier. Others experienced shifts in rainfall, wind patterns, or seasonal timing. In parts of the southern hemisphere, the story was different again, sometimes delayed, muted, or shaped by local ocean currents and landscapes. But for people living in northern Europe, Western Asia, and parts of North America, this was not an abstract climate chart. It was a reorganization of the living world. The evidence comes from many different places. Ice cores preserve tiny bubbles of ancient air, layers of snow compressed year after year, and chemical traces that record changes in temperature and atmospheric circulation. Lake sediments preserve pollen blown in from nearby plants. They contain charcoal from fires, dust from dry periods, shells from tiny organisms, and layers of mineral material washed in by changing rivers. Ocean sediments record shifts in sea surface temperatures and currents. Cave formations, tree remains, glaciers, and ancient shorelines each add part of the picture. None of these records is perfect by itself. A pollen grain cannot tell us what a particular human family felt on a particular winter morning. An ice core cannot explain whether a hunting group changed its migration route or joined another community. But when many records from many places begin pointing in the same direction, a broad pattern becomes difficult to ignore. The Younger Dryas was real. It was abrupt, and it was disruptive. In northern Europe, forests that had begun advancing in the warmer period before it were pushed back in some regions. Birch and pine gave way, or lost ground, to more open vegetation. Cold-loving plants expanded, reindeer ranges shifted. In some landscapes, growing seasons shortened. Winters became harsher. Summer warmth, which matters as much as winter cold for plants and animals, became less reliable. Imagine the difficulty of planning under those conditions. A hunting community does not need a global average temperature. It needs to know whether the animals will arrive, whether berries will ripen, whether a river crossing will remain open, whether the plants gathered every autumn will still grow in the same valley, whether snow will come early enough to block travel or melt late enough to delay the season. A few degrees of cooling can change all of that. So can a change in rainfall. A colder climate may mean drier conditions in one place, heavier snow in another, stronger winds along a coast, or a different pattern of spring flooding farther inland. The effect is not simply less warmth, it is less predictability. And unpredictability is expensive. If a herd changes its route, hunters must either follow it or find another food source. If woodland closes over an old hunting ground, the techniques that worked on an open plain may become less useful. If rainfall weakens, wetlands can shrink, and rivers can become seasonal. If storms intensify, travel by water becomes more dangerous. If neighbouring groups are being pushed into the same refuges, old exchange networks can become more important, but competition can increase too. Some communities may have moved, some may have divided into smaller groups. Some may have joined other communities through marriage, alliance, or necessity. Others may have intensified use of local foods that had once been secondary: fish, shellfish, waterfowl, nuts, wild grains, small mammals, roots and tubers. The archaeological record suggests adaptation rather than one single story of collapse. In the Levant, the eastern Mediterranean region, that includes parts of modern Israel, Palestine, Jordan, Lebanon and Syria, people associated with the Natufian culture had already begun living in more permanent or semi-permanent settlements before the Younger Dryas. They harvested wild cereals, collected nuts and fruits, hunted gazelle, and built stone structures that were more substantial than a temporary camp. Then conditions changed. Some researchers have argued that the Younger Dryas brought cooler and drier conditions to parts of the Levant, reducing the abundance of wild cereals in certain areas and placing pressure on communities that had become used to productive local landscapes. There is evidence for shifts in settlement patterns and mobility during this period, but the details remain debated. Not every Natufian site was abandoned. Not every community responded the same way. Climate was one force among many. Population, local ecology, social traditions, trade connections, and human choices all mattered too. Still, the timing is important. After the Younger Dryas ended, around 11,700 years ago, temperatures rose again. This time, the warming marked the beginning of the Holocene, the relatively stable climatic interval in which agriculture, cities, writing, and states would eventually emerge. The return of warmth did not invent farming overnight. Agriculture was not a switch flipped by better weather. People had been gathering and processing wild plants for thousands of years. They already understood seasons, seeds, soils, grinding stones, storage, and the habits of animals. The knowledge came first. The experiments came first. But a warmer, more stable climate may have made some experiments easier to repeat. When rainfall patterns became more dependable in certain regions, when growing seasons lengthened, and when wild plant resources became abundant in predictable places, communities had more opportunity to stay near favoured landscapes. They could return to the same stands of grain. They could build more durable homes. They could store food. They could invest labour in a place, because there was a reasonable chance that place would still support them next year. That does not mean the Younger Dryas caused agriculture. Human history almost never has a single cause that clean. But it may have been part of the pressure and possibility surrounding one of the biggest changes humans ever made. For generations, people had watched climates shift beneath their feet. They had adapted to warming, rising seas, moving forests, disappearing animals, and then an abrupt return to cold. By the time the Holocene began, some communities had learned a hard lesson. Survival could not depend entirely on following a landscape that never stayed still. So they began, slowly and in different ways in different places, to reshape their relationship with the land. And behind this sudden cold interval lay an even larger question. What could make a warming planet snap back into near-glacial conditions so quickly? The leading explanation begins with water. Not ordinary river water, but an amount of fresh water so vast it is hard to picture. At the end of the last ice age, huge ice sheets still covered much of northern North America and northern Europe. The Laurentide ice sheet spread across Canada and parts of the northern United States was not just a glacier in the modern sense. It was a continental mass of ice, in places several kilometers thick. As the planet warmed, that ice began to melt, and melt water began moving across the landscape. Some of it flowed through rivers, some collected in enormous lakes trapped between the retreating ice and the land. One of the largest was Lake Agassiz, a body of water that at times covered an area larger than all of the modern Great Lakes combined. It held more fresh water than almost any lake alive today. Now imagine that water searching for an exit. As the ice sheet shrank, it changed the shape of the land and opened, closed, and redirected drainage routes. Water that had once flowed south toward the Gulf of Mexico might be diverted east toward the North Atlantic. Water could spill suddenly when an ice dam failed. Rivers could be rerouted as the weight of ice lifted from the land and the ground slowly rebounded upward. This matters because the North Atlantic is not just an ocean. It is part of a planetary heat-moving system. Warm, salty surface water travels north from the tropics. As it moves toward Greenland and the seas around northern Europe, it cools. Cold water is denser than warm water. Saltier water is denser than fresher water. When the water becomes cold and salty enough, it sinks deep into the ocean. That sinking helps pull more warm water northward behind it. This system is often described as the Atlantic Meridional Overturning Circulation. The name is a mouthful, so think of it as a vast conveyor of heat. Not a neat mechanical belt, not something that moves at one steady speed. It is a complicated, shifting network of currents, winds, sea ice, temperature and salinity. But its overall effect is clear. It helps carry heat into the North Atlantic region. And that heat matters enormously. Without the ocean's northward transport of warmth, northwestern Europe would be much colder than its latitude suggests. The same is true in different ways for the whole North Atlantic climate system. Ocean circulation helps determine where storms travel, where sea ice forms, how much moisture reaches land, and how seasons unfold. Then comes the fresh water. Fresh water is lighter than seawater. If enough fresh water enters the North Atlantic quickly, it can form a less salty surface layer. That layer is harder to sink, and if surface water does not sink as efficiently, the larger overturning circulation can weaken. Less warm water moving north, more sea ice, changed winds, changed rainfall. A colder North Atlantic. This is the basic mechanism many scientists think helped trigger or intensify the Younger Dryas. The sequence is almost elegantly cruel. Warming melts ice. Melting ice releases fresh water. Fresh water disrupts the ocean circulation that carries warmth north. The region cools sharply even while the wider planet is continuing its long transition out of the Ice Age. In other words, the cold interval may have been caused at least partly by warming. That sounds backwards only because climate does not behave like a household thermostat. Turn up the global temperature and every place does not simply become a little warmer. Earth has thresholds, feedbacks, and systems connected across enormous distances. Add enough fresh water in the right place at the right time, and the response can be abrupt. There is evidence that the North Atlantic circulation changed during the Younger Dryas. Marine sediments contain signs of shifting water masses and changing sea surface conditions. Greenland ice cores show the sharp regional cooling. Records from around the world show changes in rainfall belts, monsoons, vegetation, and atmospheric dust that are consistent with a major reorganization of the climate system. But there is an important word in that sentence: consistent. Scientists are still working out exactly where the fresh water came from, how quickly it entered the ocean, and which route it followed. Lake Agassiz is a leading suspect, but it is not a solved detective story. The ancient landscape has been transformed by later erosion, rising seas, sediments, and thousands of years of human activity. Meltwater channels can be difficult to date precisely. A flood may leave an incomplete signature, and a huge freshwater release does not have to arrive as one spectacular wall of water to affect ocean circulation. It could come through several pulses, multiple drainage pathways, or sustained changes in seasonal flow. Some researchers argue for a sudden outburst. Others favour a more complicated combination of ice sheet collapse, altered drainage, sea ice feedbacks, and changes already underway in the ocean. The real answer may not be one event, one lake, one broken dam, or one dramatic day. It may be a chain reaction. The retreating ice sheets were changing more than rivers. They were changing sea level during the last ice age. So much water was locked up in ice that global sea level was more than 100 meters lower than it is today. As the ice melted, coastlines moved inland, plains became shallow seas, river valleys flooded, land bridges disappeared. But sea level rise was not smooth either. There were periods when it accelerated, as ice sheets lost mass rapidly. There were regional differences caused by the strange flexibility of the planet itself. Where an ice sheet had pressed down on the crust for thousands of years, the land began rising after the ice retreated. In other places, the shifting weight of water caused land to sink. A coastline could be changing because the sea was rising, because the land was falling, or because both were happening together. For communities living near rivers, estuaries, and coasts, these were not separate events. The climate shifted, water routes shifted, animal habitats shifted, shorelines shifted. A familiar camp beside a river mouth could, over generations, become a place far from the coast, or vanish beneath the sea. And still, even this does not mean that every abrupt climate change needs one cinematic cause. Earth's climate contains its own amplifiers. Sea ice reflects sunlight back into space. When more ice forms, cooling can intensify. When ice melts, darker ocean water absorbs more heat, strengthening warming. Changes in ocean circulation alter rainfall. Changed rainfall can alter vegetation. Vegetation changes the way land reflects sunlight, holds moisture, and sends water back into the atmosphere. A relatively modest push can sometimes set several feedbacks in motion. Think of a canoe floating on a quiet lake. A small shift in weight may do almost nothing. but lean just far enough, and suddenly the balance changes. The canoe does not need an explosion to tip. It only needs to pass a threshold. The Younger Dryas may have been something like that. A world already unstable from rapidly melting ice crossed into a different state. Freshwater likely played a major role. Ocean circulation likely weakened. Sea ice and atmospheric changes likely helped maintain the cold. But the exact proportions remain under investigation. That uncertainty is not a weakness in the science. It is the science being honest about a difficult problem. We are trying to reconstruct an event nearly 13,000 years old from chemical traces in ice, shells buried in mud, grains of pollen, ancient shorelines, lake deposits, and computer models of an ocean no human ever saw. Each record has gaps. Each method has limits. The remarkable thing is not that scholars still debate details. The remarkable thing is that so many independent clues converge on the same broad conclusion. The climate system changed rapidly, and changes in melting ice and Atlantic circulation were deeply involved. Sometimes that debate gets misused. If scientists disagree over the exact route of meltwater, some people conclude that anything is possible. Perhaps, they say, the uncertainty proves there was a lost global civilization wiped out by a single catastrophe and erased from history. But uncertainty does not work that way. Not knowing every detail of a river's path does not prove a vanished empire stood beside it. A complicated explanation for climate change does not require an ancient advanced civilization. The evidence for the Younger Dryas is extraordinary on its own: real climate disruption, real flooding, real ecological change, and real human communities adapting to a world that had become less predictable. That is already dramatic enough, and somewhere beyond the shifting rivers and melting ice. Another possibility was being proposed. Not a change from within Earth's climate system, but a visitor from the sky. The idea is called the Younger Dryas Impact Hypothesis, and in its most dramatic form, it goes like this. Around 12,800 years ago, as the planet was warming out of the Ice Age, a large comet or asteroid entered Earth's atmosphere. It may have exploded in the air. It may have broken into several pieces. Some fragments may have struck the ice sheet covering North America. The impacts and airbursts, according to the hypothesis, produced enormous fires, blasted dust and soot into the atmosphere, destabilized the ice sheets, and helped trigger the sudden cold of the Younger Dryas. It is a powerful story, a world of hunters and gatherers watching the sky burn. Forests catching fire, great animals dying, the climate turning cold again. Coastlines beginning their slow retreat, a catastrophe arriving not through a gradual change in weather, but from above. And there are reasons some scientists took the possibility seriously. At a number of archaeological and geological sites in North America, Europe, and elsewhere, researchers have identified a thin layer of sediment dated roughly to the beginning of the Younger Dryas. In some of these layers, they reported unusual materials: tiny glassy beads called microspherules, melted particles that might form in extremely high temperatures, nanodiamonds, microscopic diamonds that can sometimes be associated with impacts, elevated concentrations of platinum, a rare metal more common in some meteorites than in Earth's crust. There are also dark, organic rich layers at some North American sites, often called black mats. These deposits appear around the same broad period and may reflect major environmental change, wetter ground in some places, changing vegetation, altered water tables, the reorganization of ecosystems as the climate shifted. For supporters of the impact hypothesis, these clues seem to fit together. A cosmic object arrives. The heat creates unusual minerals. Fires leave charcoal and soot. Atmospheric dust blocks sunlight. Ice sheets are disturbed. Fresh water enters the North Atlantic. Ocean circulation weakens. The Younger Dryas begins. And then there is the question everyone asks. Where is the crater? One candidate is the Hiawatha structure beneath the ice of northwestern Greenland. It is a large circular depression buried under more than a kilometre of ice. It appears to have been created by an impact, and its discovery immediately drew attention. Could this be the smoking gun? Could a meteorite strike near Greenland have destabilized the northern ice sheets at exactly the wrong moment? Maybe, but maybe not. The problem is dating. Establishing the age of a crater beneath moving ice, buried sediments and glacial debris is extremely difficult. Evidence so far indicates that Hiawatha is an impact structure, but it has not been securely shown to date to the onset of the Younger Dryas. It could be much older. An impact crater is not automatically a Younger Dryas crater simply because it exists beneath an ice sheet. Other proposed sites have faced similar problems. Some have turned out to be uncertain landforms. Some lack evidence of a confirmed impact. Some may have been created by ordinary geological processes, however strange they look from above. Earth is extremely good at making circles, scars, ridges and depressions without help from space. The evidence in the sediment layers is debated too. Nanodiamonds are real. Platinum anomalies are real at some sites. Microspherules and charcoal are real. The question is not whether researchers found interesting things. The question is whether all those things come from one shared cause at one precise moment across the whole planet. That is much harder to demonstrate. A layer of charcoal can come from wildfire. And wildfires were common during a time of changing climate, shifting vegetation and drying landscapes. Microspherules can form through volcanic activity, industrial contamination in more recent sediments, ordinary terrestrial processes, or other high-temperature events. Platinum can arrive in cosmic dust over long periods, can be concentrated by local sediment processes, or can be difficult to measure consistently from one laboratory to another. Then there is the issue of timing. A hypothesis about a single, sudden global event needs the evidence to line up very closely, not just somewhere around 13,000 years ago. It needs to appear at the same geological moment, in well-dated layers across distant regions. But ancient sediments are rarely neat. Burrowing animals mix layers. Roots disturb soil, floods redeposit material, wind moves dust. Archaeological sites are used again and again by people over thousands of years. A thin line in the ground can look like one day in the past, while actually representing decades, centuries, or a complicated mixture of events. Many researchers therefore remain unconvinced that the impact evidence demonstrates a single comet disaster. The larger scientific picture still favours the explanation we just explored. Meltwater, weakened North Atlantic circulation, expanding sea ice, and climate feedbacks operating within an already unstable deglacial world. That does not mean the comet hypothesis is impossible. It means it is not settled, and that distinction matters. A plausible hypothesis is an idea that could explain evidence and deserves testing. A settled conclusion is something different. It is an explanation supported by repeated observations, independent methods, careful dating, and broad agreement that competing explanations do not fit as well. The Younger Dryas impact hypothesis remains in the first category. It has generated research. It has prompted scientists to re-examine sediments, search for craters, improve dating techniques, and ask useful questions about abrupt climate change. But it has not produced the kind of unambiguous, widely accepted evidence that would end the debate. Still, the idea has an extraordinary grip on the public imagination, partly because comets are ancient symbols of warning. They arrive without invitation, cross the sky like burning messages, and then vanish. Partly because we know impacts can change life on Earth. 66 million years ago, an asteroid strike helped end the age of dinosaurs. So the thought of another impact reshaping the human world does not sound absurd. It sounds frighteningly possible, and partly because a single fiery event is easier to imagine than an ocean circulation shift. A comet gives us a villain, a crater gives us a location. A blast gives us a beginning, but climate systems are more patient and more difficult. They work through currents, ice, dust, rainfall, and feedbacks. They can transform the world without one visible moment when everything changes. Whether a cosmic visitor played any role or not, the people living through the end of the Ice Age did not need to see a comet to experience catastrophe. Their shorelines were already moving, their river valleys were changing, and over thousands of years, the rising sea would erase some of the landscapes where their stories began. And this is the part of the story that is easy to forget. When we imagine the Ice Age, we tend to picture more ice, larger glaciers, mammoths walking across frozen grasslands. But there was another difference, one that changed the shape of every continent. The oceans were lower. At the coldest point of the last Ice Age, around 20,000 years ago, so much water was trapped in enormous ice sheets that global sea level stood roughly 120 meters lower than it does today. That is nearly 400 feet. A height difficult to picture until you imagine standing at the top of a 30-story building and looking down at the sea. That much lower. The coastline was not where it is now. It was sometimes tens of miles away. In shallow regions it could be hundreds of miles away. The English Channel was not a channel in the form we know today. Britain was connected to continental Europe by a broad lowland plain. The North Sea was not entirely sea. It contained rivers, marshes, lakes, forests, and open grassland. Archaeologists call this lost territory Doggerland. For thousands of years it was a real landscape occupied by animals and almost certainly by people. The Persian Gulf was largely a dry basin crossed by river systems. Southeast Asia was joined together in a huge peninsula known as Sunderland. Modern islands like Borneo, Java and Sumatra were connected to mainland Asia by land. Australia, New Guinea and Tasmania were closer together too, separated by narrower channels and exposed plains. Across the far north, Beringia linked Siberia and Alaska. Not a narrow land bridge with people marching across in single file, but a vast cold grassland, sometimes hundreds of miles wide. A world of mammoths, bison, horses and hunters. A world that no longer exists because it is now beneath the Bering Sea. This was the geography into which human societies expanded at the end of the Ice Age. And then the ice began to melt, not in one single flood, not as a wall of water racing around the planet in a few days. The real process was slower than that, but in human terms it was still dramatic. Generation after generation watched familiar shorelines move inland. Estuaries widened. Salt water pushed farther up river valleys. Coastal springs became brackish. Beaches disappeared. Low fields became marshes. Then tidal flats. Then open water. Over roughly 10,000 years the sea rose by around 120 meters. The rate was uneven at some times. Sea level rose gradually, perhaps slowly enough that communities could shift their camps inland over many lifetimes. At other moments, during major meltwater pulses, it may have risen much faster. Not fast enough to drown a continent overnight, but fast enough to transform coastlines over a few human generations. Imagine living near a river mouth around 14,000 years ago. Your grandparents remembered the sea far away. Your parents saw it closer. By the time you were old, salt water might have reached places where you once hunted deer or gathered reeds. The old paths would still exist for a while. Then they would become muddy channels. Then shallow water. Then nothing visible at all. A place can vanish without exploding. it can vanish quietly, one season at a time, and because coastlines are attractive places to live, this matters enormously. Coastal plains offer fresh water, fish, shellfish, birds, wetlands, edible plants, and easy travel by river and shore. River mouths are especially rich environments. They bring together land, sea, and freshwater ecosystems. For mobile hunter-gatherers, they could be ideal places to return to year after year. So if people lived along the coasts of the late Ice Age, and there is every reason to think many did, then a large part of their archaeological world is now underwater. This creates a serious problem. Most archaeology happens on land because that is where archaeologists can walk, dig, map, and return season after season. But the land surface of 15,000 years ago is often far offshore today. Sometimes it lies beneath shallow water, sometimes beneath 50 metres, 80 metres, even more than 100 metres of sea. It may be covered by sand, mud, storms, fishing disturbance, harbour construction, and layers of sediment deposited over thousands of years. Finding an ancient camp beneath all of that is difficult. Excavating it is harder still. Underwater archaeologists use sonar, sediment cores, remotely operated vehicles, divers, and careful mapping of drowned river channels. They can identify old shorelines, ancient lakes, peat deposits, forests drowned by the sea, and stone tools washed from the seabed. Fishermen in the North Sea have pulled mammoth bones, antlers, and prehistoric artifacts from nets. Submerged landscapes have been mapped off Britain, in the Mediterranean, around Southeast Asia, and along many other continental shelves. But mapping a drowned landscape is not the same as finding a village. Wood rots, plant fibres decay, skin shelters leave little trace. Small camps can be scattered by waves before they are buried, and the people of the late Ice Age often built with materials that were perfectly suited to their lives, but terrible at surviving 12,000 years beneath the ocean. So yes, important early settlements may remain underwater. Perhaps many of them do. There may be coastal camps, fishing places, burial grounds, tool workshops, and seasonal gathering sites now hidden beneath modern seas. There may be evidence that changes how we understand the routes people travelled, the foods they ate, and the social networks they maintained. But there is an important boundary here. Drowned coastlines do not automatically prove that a global advanced civilization existed before known history. They do not prove lost cities with metal machines, vast empires, or a single forgotten civilization that taught the world everything it knew. The sea has hidden landscapes. That much is certain. The sea has almost certainly hidden human sites. That is highly likely. But archaeology still has to follow evidence. A submerged forest is not a palace. A stone tool on the seabed is not proof of an empire. A lost plain is not Atlantis simply because it is lost. What the drowned coastlines really show is something both simpler and more profound. Our picture of the ancient past is incomplete, not because history is a conspiracy, not because every scholar is ignoring some forbidden civilization, but because the places where people may have lived most successfully are often the places the rising ocean took first. And as the coastlines vanished, people were forced inland toward river valleys, uplands, and eventually the landscapes where the first permanent monuments would rise from the earth. And one of the most remarkable of those landscapes lies in southeastern Anatolia, in what is now Turkey. There, on a limestone ridge overlooking the plains, archaeologists found something that seemed almost out of place in the deep past. Göbekli Tepe. Its name means Potbelly Hill. For centuries it looked like an ordinary artificial mound, a rounded rise in the landscape made of soil, stones and debris. Local people knew it was there. Surveyors had noticed fragments of worked flint on the surface. But few imagined that beneath the hill stood some of the oldest known monumental stone structures in the world. When excavation began in the 1990s, the surprise was immediate. Buried beneath layers of fill were large circular and oval enclosures. At the centre of each stood two enormous T-shaped limestone pillars, sometimes more than 5 meters tall and weighing several tons. Around them, smaller pillars formed walls or rings. Many were carved with animals: foxes, snakes, wild boars, birds, insects, and powerful cats. Some pillars appear to have arms, hands, belts, and garments carved into their surfaces, suggesting that the stones themselves may have represented stylized human figures. These were not random rocks arranged by accident, they were planned monuments. The builders quarried limestone nearby, shaped the pillars with stone tools, moved them uphill, placed them in prepared sockets, and created enclosed spaces that seemed to have had special meaning. Then, after some period of use, they deliberately filled many of the enclosures with rubble, broken stone, animal bone, and soil. New structures were built nearby. Over generations, the hill gradually became the mound archaeologists would one day excavate. And the dates were astonishing. The earliest major phases of Göbekli Tepe go back to roughly 9,600 BCE, more than 11,000 years ago. That places them near the beginning of the Holocene, after the Younger Dryas cold period had begun to loosen its grip on Southwest Asia. This was before pottery, before metal, before writing, before cities, kings and tax collectors, before the great river civilizations of Mesopotamia and Egypt, by many thousands of years. More surprisingly, Göbekli Tepe was built before agriculture had become fully established in the region. For a long time, a simple story dominated popular ideas about civilization. First, people learned to farm. Farming produced food surpluses. Surpluses allowed larger settled populations. Larger populations created temples, priests, social classes, and monumental architecture. In that story, the monument comes near the end. Göbekli Tepe seemed to put a monument near the beginning. The people who built its earliest enclosures lived in a world still rich with wild resources. Animal bones found at the site include gazelle, wild cattle, wild boar, and other game. The surrounding region contained wild cereals, pistachios, almonds, fruits, and edible plants. These communities knew the land closely. They hunted, gathered, processed food, made sophisticated stone tools, and moved through a landscape that was becoming warmer and in many places more productive. They were not primitive people stumbling through the wilderness. They were skilled, organized, and capable of gathering labor for projects that had no obvious immediate survival value. Or at least no obvious survival value to us. Why build massive stone circles on a hill? The honest answer is that we do not know. Göbekli Tepe contains no written records. No inscription tells us who entered the enclosures, what they believed, what ceremonies took place there, or why some rooms were buried and replaced. Archaeologists can study the layout, the carvings, the tools, the bones, and the traces of activity. But meaning is harder to excavate than stone. The site is often described as a temple, and it may well have been a place for ritual gatherings. Its architecture does not resemble an ordinary house. The central pillars, animal carvings, carefully enclosed spaces, and repeated rebuilding all suggest that it mattered deeply to the people who used it. But temple can also make us imagine a fully formed priesthood, a settled religious institution, and beliefs we cannot actually prove. Perhaps groups came to the ridge seasonally, meeting relatives, exchanging gifts, arranging marriages, sharing news, feasting, and performing ceremonies. Perhaps the work itself helped bind scattered communities together. Building a monument is not only about the finished structure, it is also about the people who arrive, cooperate, eat together, argue, tell stories, make promises, and return home with new connections. A stone enclosure can be a kind of social technology. It gives large numbers of people a reason to gather. It creates shared memories. It tells everyone who sees it that this place matters, that the people associated with it can organize effort across time. And that may be one of the keys to understanding the world after the Ice Age. Göbekli Tepe did not appear in an empty landscape. It belonged to a wider transformation unfolding across Southwest Asia, especially the Fertile Crescent. Villages were becoming more substantial. People were spending longer periods in particular places. They were harvesting wild grains, storing food, managing landscapes, and gradually developing closer relationships with plants and animals. Nearby sites show different parts of this process. Some communities built houses, some cultivated cereals. Some began the long, uneven transition toward domesticated sheep, goats, wheat, and barley. This was not a single invention happening on one Tuesday afternoon. It was a slow regional change, with many experiments, failures, local traditions, and different ways of living existing side by side. Göbekli Tepe belongs to that threshold. Its builders may not have been farmers in the later sense, but they were not simply wandering bands untouched by settlement or food production either. The old categories become blurry here. Hunter-gatherer, farmer, nomad, villager. In real life, people could move between these worlds, gathering wild food while tending plants, hunting animals while returning to seasonal settlements, participating in rituals at one place and living elsewhere for much of the year. This is why Göbekli Tepe is so important, not because it proves a lost super-civilization, not because it reveals a vanished global empire with secret technology. The tools are there, the quarries are there, the methods of carving are understandable. The site shows extraordinary human cooperation, not impossible human achievement. Its real lesson is quieter. Human societies were becoming complex long before cities appeared. People were capable of symbolic thought, large-scale coordination, architecture, ritual, and regional networks without writing, bronze, or permanent urban life. The road to civilization was not a straight staircase, with farming on the first step and monuments at the top. It was more like a wide valley crossed by many paths. Some paths led toward settled villages, some toward farming, some toward ceremonial centres, some disappeared, some joined together, and on one hill in southeastern Anatolia, people raised stones so large and so carefully carved that more than 11,000 years later, they still force us to reconsider what the first builders of the post-Ice Age world were capable of. That surprise leads naturally to a much larger question. If Göbekli Tepe could remain buried for thousands of years beneath an ordinary-looking hill, what else might still be hidden? Could there be lost settlements beneath forests, deserts, farms, or modern cities? Could whole cultures have vanished from the record? And if sea level rose after the Ice Age and swallowed ancient coastlines, could some of humanity's earliest experiments with permanent settlement now lie under hundreds of feet of water? The answer, in the first sense, is absolutely yes. Archaeology is not a complete library of the human past. It is more like a library after a flood, a fire, several earthquakes, and thousands of years of people borrowing pages for other purposes. A few books remain, most survive as scraps, and archaeologists have to reconstruct entire worlds from whatever the ground happened to preserve. Stone survives well, so does fired clay. Bone can survive under the right conditions. Metal sometimes survives, although iron often rusts away and organic materials are much more fragile. But wood decays, leather decays, rope, baskets, clothing, boats, wooden houses, fishing nets, and most of the objects people touched every day usually disappear. A village built largely from timber, reeds, mud, and thatch may leave only stains in the soil, a few post holes, fragments of charcoal, broken tools, and perhaps discarded food bones. If no one excavates that exact patch of ground, the village can remain invisible. And even when it is found, understanding it is difficult. Imagine an archaeologist of the distant future digging through the remains of a modern campsite. They might find a few bottle caps, a fire pit, plastic fragments, and metal stakes. From that, could they reconstruct the conversations, relationships, jokes, fears, plans, and private beliefs of the people who stayed there? Probably not. They could infer some things. They would know people ate, slept, used manufactured goods, and made fire. But the human story behind those objects would remain mostly out of reach. That is the basic challenge of archaeology. It works from traces, not memories. Sometimes those traces are astonishingly rich. Pompeii, buried by volcanic ash, preserved streets, homes, graffiti, bakeries, gardens, and even the shapes of people caught in the eruption. Egyptian tombs preserved wood, cloth, food, and painted scenes because the dry desert slowed decay. Waterlogged sites in northern Europe have preserved wooden tools, wheels, and trackways that would have rotted almost everywhere else. But those are exceptions. Preservation is selective. The past is not equally visible in all places, and the lost coastlines of the Ice Age may be the greatest missing chapter of all. During the last glacial maximum around 20,000 years ago, so much water was locked in ice sheets that global sea level was more than 100 meters lower than it is today. The shoreline lay far beyond many modern coasts. Areas that are now shallow sea were once plains, river valleys, marshes, lake shores, and estuaries. These were exactly the kinds of places people often preferred. Fresh water, fish, birds, shellfish, plant foods, easy travel by river and coast. Rich hunting grounds. Places where groups could meet, trade, settle seasonally, and perhaps gradually build more permanent communities. Then the ice melted. Over thousands of years, the sea rose and moved inland. Coastline after coastline disappeared. In places such as the North Sea, the Persian Gulf, Southeast Asia, and the continental shelves around the Americas, enormous landscapes now lie underwater. Some archaeologists call the drowned plain beneath the North Sea Doggerland. At its broadest, it connected what are now Britain and continental Europe. People lived there. They hunted, gathered, travelled through it, and likely knew its rivers and marshes as intimately as any later people knew their fields. Today, fishing boats occasionally bring up ancient bones, stone tools, and fragments of peat from the seabed. So yes, there are lost landscapes. There may be undiscovered settlements. There may be ceremonial sites, burial grounds, workshops, and villages now covered by water or buried under sediment. At this point in the story, let your mind rest for a moment. If you enjoy these deep historical mysteries, the channel's book about 12 unexplained mysteries is available on the website, and the link is in the description. Now, the fact that archaeology is incomplete does not mean every claim about the ancient past is equally likely. This is where an important distinction has to be made. A lost local culture is one thing. A worldwide technological civilization is something very different. A small coastal community could vanish with remarkably little trace if it used wood, fibre, shell, bone, and simple stone tools. And if its homes were flooded or eroded, much of its material world might be gone. Even a fairly large regional society can remain obscure if few of its sites have been surveyed, excavated, or preserved. That is not speculation. Archaeology discovers previously unknown cultures regularly. New aerial surveys, satellite images, ground-penetrating radar, and LiDAR scans through forest canopy have revealed roads, settlements, terraces, and earthworks in places once thought nearly empty. But a civilization with cities, metal industries, long-distance trade, and global networks would leave a different kind of signature. Large populations create large waste streams. They quarry stone. They cut forests. They reshape soils. They build roads, ports, mines, canals, walls, warehouses, and cemeteries. Metalworking produces slag, the glassy waste left by smelting ore. Intensive agriculture leaves pollen changes, erosion patterns, charcoal layers, and altered landscapes. Long-distance trade spreads distinctive materials far from their source, and industry leaves traces on a scale that is hard to hide. A civilization manufacturing large quantities of bronze, iron, steel, concrete, glass, or ceramics would scatter chemical and physical evidence across many regions. A civilization using fossil fuels on a modern scale would leave an unmistakable signal in the atmosphere: sediments and ice. A global society would not vanish like a single wooden hut beside a river. It would leave echoes everywhere. This does not mean that we know everything. We do not. It means that uncertainty has boundaries. We can reasonably wonder about submerged villages on ancient coasts. We can expect surprises in remote forests, deserts, and river deltas. We can admit that the people of the Ice Age may have had social systems, rituals, skills, and traditions far richer than the objects they left behind suggest. But wonder is strongest when it does not have to ignore evidence. Göbekli Tepe is extraordinary precisely because it is real. Its stones can be measured, its tools can be studied, its animal bones can be counted, its layers can be dated. It expands our sense of the past without requiring us to invent machines, empires, or continents for which the Earth has provided no convincing trace. The unknown is vast, but the unknown is not a blank check. And as we turn from buried monuments to the oldest stories people told about catastrophe, that difference will matter, because sometimes a story can preserve a memory of a real disaster, and sometimes it can become much larger than the event that first inspired it. Flood stories are found almost everywhere. In Mesopotamia, the oldest surviving versions appear on clay tablets thousands of years old. In the Epic of Atrahasis, the gods decide that humanity has become too numerous, too noisy, too difficult to tolerate. They send a flood to wipe people out, but one man is warned. He builds a great boat, seals it with bitumen, brings aboard his family, animals and supplies, and survives while the world outside is destroyed. Later, in the Epic of Gilgamesh, the same basic story appears again. The survivor is called Utnapishtim. He tells Gilgamesh how the storm came, how the sky turned dark, how even the gods became afraid of the destruction they had unleashed. After days of water and wind, the boat comes to rest on a mountain. Birds are sent out to search for dry land. Finally, a sacrifice is offered. The gods gather around its smell, and the survivors begin again. Anyone familiar with the Hebrew Bible will notice the resemblance. In Genesis, Noah is warned of a coming flood. He builds an ark. He brings his household and animals. Rain falls. The waters rise. A bird is sent out. The ark comes to rest. And after the flood, a covenant is made between God and humanity, marked by the rainbow. These stories are not identical. Their meanings are different. Their gods are different. Their moral worlds are different. But they belong to the same broad cultural landscape of the ancient Near East, where stories travelled along trade routes, through migrations, marriages, conquests, and generations of people sitting beside fires, telling old tales in new languages. And Mesopotamia was a place where floods were never abstract. The Tigris and Euphrates could be generous rivers. They made agriculture possible in a dry land. Their waters carried silt onto fields, supported cities, and connected communities by boat. But they could also rise suddenly, break canals, destroy mud brick homes, drown livestock, and turn flat farmland into a brown inland sea. A flood in a river valley does not have to cover the entire planet to feel like the end of the world. If your whole world is a town, its fields, its temple, its storehouses, and the villages visible across the plain, then the destruction of that world is total. The water may only extend for a few dozen miles, but every familiar landmark is gone. Every path is erased. The dead may be unreachable. Food stores may rot. Families may be scattered. For the people who endure it, there is no need to imagine a global disaster. Their own world has already ended. Similar stories appear far beyond Mesopotamia. In Greek tradition, Deucalion and his wife Pyrrha survive a flood sent by Zeus. They escape in a chest or boat, reach dry land, and repopulate the world in a strange symbolic way, throwing stones behind them that become new people. In India, the ancient story of Manu tells of a tiny fish that warns a righteous man of a coming flood. Manu protects the fish as it grows larger and larger. Eventually, the fish reveals itself as a divine being and instructs Manu to build a boat. When the waters come, the fish guides the vessel to safety. There are flood traditions in parts of China, in indigenous traditions across the Americas, among island societies in the Pacific, and in communities across Africa and Europe. Some describe a divine punishment, some describe a cosmic reset. Some tell of a family, a brother and sister, or a small group surviving on a mountain, a raft, or a floating vessel. Some are not really about a flood at all, but about a great water, a drowned landscape, or an ancestral migration away from a rising sea. It is tempting to gather all these stories together and say they must preserve one single event: a global flood, a comet, the end of the Ice Age, a memory carried intact for 10,000 years. The idea has obvious appeal. Sea levels did rise dramatically after the last Ice Age. Not in one continuous wall of water racing across every coast, but through a long and uneven process lasting thousands of years. In some periods, the rise was relatively rapid. Low-lying plains vanished. Estuaries widened. River mouths moved inland. Islands became islands. Communities that had lived near ancient shorelines had to retreat, adapt, or leave. For people living on those coasts, the change could have been visible within a lifetime. A marsh becoming tidal water, a hunting ground becoming a bay, a familiar path disappearing beneath the sea, old campsites swallowed by storms and tides. Grandparents remembering land where grandchildren saw only water. That kind of experience can become a story, and stories can last a very long time. They can preserve the outline of a place even after the place is gone. They can remember that there was once dry land beyond the horizon. They can warn that the sea is powerful, that rivers can betray, that survival may depend on preparation, luck, cooperation, or simply being high enough when the water comes. But there is a limit to what we can say. Myths are not geological reports. They do not give us a neat record of sea level curves, dates, rainfall totals, or exact coastlines. A flood story may contain memories of real flooding, but it has also been shaped by religion, poetry, politics, morality, and retelling. Over centuries, one local catastrophe can become universal. A river flood can become a flood of the whole earth. A family's escape can become the rebirth of humanity. That does not make the story false in the deeper sense. It means stories preserve a different kind of truth. They preserve the feeling of standing before forces too large to control. They preserve the terror of watching ordinary life disappear. They preserve the question every survivor faces afterward. Why did we live when others did not? What do we carry forward? How do we begin again? And perhaps that is why flood stories are so enduring. They are not only about water, they are about vulnerability, about the fragile line between a settled life and chaos, about storehouses, homes, laws, temples, families and memories, all depending on seasons that usually behave as expected. They are also about renewal. The ark reaches land. The mountain emerges, the waters recede, seeds are planted, animals return. People make promises. The world after disaster is not the same world, but it is still a world where life continues, and that is a message civilization has needed more than once. Because floods were not the only disasters remembered by human societies. Sometimes the danger came not from too much water, but from a sudden failure of rain. Sometimes the danger came not from too much water, but from a sudden failure of rain. Around 8,200 years ago, long after the great ice sheets had begun retreating, and long before the first cities of Mesopotamia rose from the floodplain, the climate shifted again. Not everywhere in the same way. Not with a single storm, a single terrible winter, or a single obvious line between before and after. But the evidence appears in ice cores from Greenland, in cave deposits, lake sediments, pollen records and mud gathered from the ocean floor. For a relatively brief period, perhaps a century and a half, with its harshest phase lasting only a few decades, temperatures around the North Atlantic dropped sharply. Some regions became colder, others became drier. Rain belts shifted, monsoons weakened. Places that had depended on predictable seasonal water found that predictability becoming less reliable. This is what climate scientists call the 8.2 kiloyear event. The name is not very poetic. It simply means the event happened about 8,200 years before the present. But for the people living through it, there would have been no need for a name. They would have known it as failed harvests, as springs arriving late, as grazing land drying out, as wells becoming shallow, as arguments over water, pasture, stored grain, and the difficult question of whether to stay or leave. The likely trigger lay far to the north, in a world of melting ice and enormous glacial lakes. At the end of the Ice Age, much of northern North America was still shaped by the remains of the Laurentide ice sheet. As that ice melted, it created vast lakes held back by unstable walls of ice and sediment. One of the largest was Lake Agassiz, a body of fresh water so immense that it would have dwarfed all of today's Great Lakes combined. For centuries this water was trapped. Then, around 8,200 years ago, part of the barrier failed. A huge volume of fresh water drained northward, probably through the Hudson Bay region, and entered the North Atlantic. Imagine it. Not a biblical flood washing across the whole world. Not a wave visible from every shore, but an immense release of cold fresh water into an ocean system driven partly by differences in temperature and saltiness. Normally, salty surface water in the North Atlantic cools, becomes dense and sinks. This sinking helps power a vast pattern of ocean circulation, carrying warmth northward and influencing weather far beyond the sea itself. Add enough cold fresh water, and the surface becomes less salty, less dense, less likely to sink. The circulation did not stop completely, but many researchers think it weakened. And when it weakened, the North Atlantic region cooled. That cooling rippled outward through the atmosphere. Storm tracks changed, rainfall patterns moved. The African and Asian monsoon systems appear to have weakened in some areas. Parts of the Middle East experienced drier conditions. In Europe, the picture was mixed, with some regions becoming cooler and wetter, while others faced reduced growing seasons and unpredictable weather. This matters because 8,200 years ago, people were beginning to build lives around farming. Agriculture was still young in many parts of the world. Wheat, barley, sheep, goats, cattle, and pigs had spread outward from early farming communities in Southwest Asia. Villages were growing. Houses were becoming more permanent. Fields had to be planted at the right time. Herds needed grass and water. Food stores had to last until the next harvest. A hunter-gatherer group can sometimes respond to a bad season by widening its search, relying on different foods, or joining relatives elsewhere. Farmers can move too, of course, but farming ties people to particular places, to cleared fields, to irrigation channels, to stored seed, to orchards that take years to establish, to houses built by grandparents and graves holding ancestors. That makes a shift in rainfall more than an inconvenience. In the Levant, Anatolia, and northern Mesopotamia, archaeologists have found evidence that some settlements were reorganized, reduced, or abandoned around this broad period. But this is where the story becomes complicated. A village can be deserted for many reasons. Soil may be exhausted, disease may spread, trade routes may change. Families may divide. New land may simply look more promising than old land. Climate stress may have contributed. It cannot explain every empty house. In some places, dry conditions may have pushed people toward rivers, springs, and wetter valleys. In others, communities may have expanded their herds, changed crops, intensified food storage, or formed stronger exchange networks with neighbouring groups. A bad harvest is easier to survive if someone else had a better one. But that kind of safety depends on trust, distance, and whether the neighbouring community has enough to spare. The 8.2 kiloyear event did not erase civilization, because civilization, as we usually imagine, it had not yet fully arrived. There were no pharaohs overseeing grain fleets, no Bronze Age palaces issuing ration tablets, no empire-wide roads carrying emergency supplies, but there were already villages, farming traditions, trade connections, sacred places and communities deeply invested in the landscapes around them. And those landscapes were changing. It is tempting, especially in a story about repeating cycles, to place this event beside the Younger Dryas and draw a clean line between them. The Younger Dryas had also involved abrupt cooling, and it had also been connected, at least in part, to disruptions in North Atlantic Ocean circulation. But the dates do not form a perfect rhythm. The Younger Dryas ended roughly 11,700 years ago. The 8.2 kiloyear event came about 3,500 years later. That is not a 12,000-year clock. It is a reminder that Earth's climate has thresholds. Ice sheets melt, lakes drain, ocean currents shift, rain belts wander, and human societies, even small ones, must respond to conditions they did not choose. Some communities suffered, some moved, some adapted so quietly that archaeology barely notices them. And some may have emerged stronger, carrying new farming methods, new alliances, and new reasons to build systems capable of surviving the next bad season. But as villages grew into towns and towns became connected by trade, another kind of vulnerability was beginning to take shape, not the vulnerability of one field waiting for rain. The vulnerability of an entire world depending on everyone else. By the late Bronze Age, that vulnerability had become enormous. Around 1250 BCE, the Eastern Mediterranean was not a collection of isolated kingdoms waiting quietly behind their walls. It was a connected world, a world of royal letters, merchant ships, tribute payments, marriage alliances, diplomatic gifts, military promises and cargoes moving from port to port. Egyptian pharaohs exchanged messages with Hittite kings in Anatolia. Mycenaean rulers in Greece imported goods from Cyprus, the Levant, and Egypt. Cities along the Syrian coast, especially places like Ugarit, acted as busy nodes in the network, receiving copper, tin, timber, grain, luxury textiles, ivory, glass, pottery, wine, and ideas. Bronze itself tells the story. To make bronze, you need copper and tin. Copper could be found in several places, including Cyprus. Tin was much rarer, often coming from distant regions through long chains of exchange. A sword made in Greece might depend on metal mined far away, carried through multiple kingdoms, traded by people speaking different languages, and finally shaped by specialists employed by a palace. The whole system worked because ships arrived, roads remained open, harvests were sufficient, kings stayed in power, and everyone more or less kept their promises. It was impressive, it was sophisticated, it was also fragile. Then, in the decades around 1200 BCE, much of this connected world began to fracture. Palaces burned, cities were abandoned, trade routes weakened or disappeared. Some kingdoms survived in reduced form. Others vanished so thoroughly that for centuries later people barely remembered they had existed. The Hittite Empire, one of the great powers of the age, collapsed. Its capital at Hattusa was abandoned. Mycenaean palace centres across mainland Greece were destroyed or severely disrupted. Ugarit, once a wealthy coastal city filled with archives and imported goods, was destroyed and never rebuilt as the same kind of centre. Egypt survived but faced attacks, internal strain, and a long decline in its influence beyond the Nile Valley. For a long time, people wanted one simple explanation. They looked for an invading army, a great earthquake, a drought, a mysterious coalition known from Egyptian inscriptions as the Sea Peoples, a single disaster sweeping across the Mediterranean, like fire through dry grass. But history is usually less tidy than that. The evidence increasingly suggests that the Bronze Age collapse was not one event. It was a cascade. Drought may have been part of it. Pollen records, lake sediments, and other climate evidence suggest that parts of the eastern Mediterranean and Near East experienced periods of increased dryness around this time. A few bad harvests can be endured. Several years of poor rainfall, falling grain stores, hungry livestock, and rising food prices can destabilize entire kingdoms. And these were kingdoms built around central control. The palace collected grain, the palace distributed rations, the palace organized labor, the palace armed soldiers, sponsored craftsmen, received foreign goods, and recorded everything on clay tablets. That system could be very efficient when conditions were stable. But if the harvest failed, the palace had less grain to distribute. If trade ships stopped coming, workshops lacked copper, tin, and other materials. If people lost confidence in the king's ability to provide protection and food, local unrest could grow. Soldiers might not be paid. Provincial governors might act independently. Rival claimants might see their chance. Then came migration. When drought, war, or hunger pushed communities from their homes, they did not vanish into the air. They moved toward places with water, grain, and defensible land. Some groups may have travelled by sea, others moved overland. Sometimes they sought refuge, sometimes they raided. Sometimes they were recruited as mercenaries by states already struggling to defend themselves. Egyptian texts describe battles against groups arriving from the north and sea. These are often gathered under the label Sea Peoples, though that name can make them sound more unified than they probably were. They may have included displaced populations, raiders, warriors, families, and opportunists from several regions, all moving through a world already coming apart. And that is the important part. The migrations may not have caused the collapse by themselves. They may have been both a cause and a consequence of it. A kingdom weakened by drought becomes easier to attack. A city destroyed by war interrupts trade. Interrupted trade creates shortages. Shortages fuel unrest. Unrest weakens military defense. More people flee. More communities become desperate. It is like a line of carefully balanced bronze cups. Tip 1. and it strikes the next. Then another, soon the whole table is shaking. The writing systems of the palace world suffered too. In Mycenaean Greece, officials used linear B tablets to record livestock, grain, workers, and offerings. When the palaces fell, that writing disappeared. Greece entered a period with far fewer written records, not because people suddenly became less intelligent, but because the institutions that trained scribes and kept archives had collapsed. In Anatolia and the Levant, archives fell silent as cities were destroyed or transformed. The old palace economies, with their bureaucrats, storerooms, workshops, and royal redistributions, could no longer function in the same way. For generations the world became smaller. Long-distance trade did not end entirely. People continued farming, fishing, herding, making pottery, building homes, raising children, telling stories and crossing the sea. But the great interconnected system of the Late Bronze Age was gone. And yet collapse was not the end of history. Out of the ruins came new societies adapted to a different world. Phoenician cities along the Levantine coast expanded their maritime trade. Aramaean kingdoms emerged across parts of Syria. Israel and Judah developed in the highlands of the southern Levant. Greek communities gradually reorganized, and centuries later would adopt an alphabet, build new city-states, and create a very different Mediterranean world. The Neo-Assyrian Empire would eventually rise in Mesopotamia, larger and more militarized than many of the states that came before it. So the Bronze Age collapse was not a final darkness. It was a transformation, brutal for those living through it, but creative in the long run. It teaches something uncomfortable about connected worlds. Complexity brings wealth, knowledge, and resilience. But when too many systems depend on one another, trouble can travel astonishingly far. A failed harvest in one region becomes a grain shortage in another. A war at one port becomes a missing shipment somewhere else. A political crisis becomes a broken alliance. And suddenly what looked like a powerful civilization begins to discover how much of its strength depended on things continuing exactly as they had before. The Maya world offers another warning against the comfort of simple stories. For years, popular books and documentaries described the so-called Maya collapse as if an entire civilization had simply vanished into the jungle. Great stone cities abandoned, temples swallowed by trees, a people erased almost overnight. It is a powerful image. It is also wrong. The Maya did not disappear. Their cities did not all fall at once. And the changes that transformed their world were not caused by one drought, one war, one environmental mistake, or one mysterious catastrophe. What happened was slower, messier, and in some ways more unsettling. During the Classic period, especially between about 250 and 900 CE, the Maya lowlands of what are now southern Mexico, Guatemala, Belize, Honduras, and El Salvador supported one of the most sophisticated urban cultures in the ancient Americas. Cities such as Tikal, Calakmul, Palenque, Copan, Caracol, and dozens of others raised pyramids above the forest canopy. Rulers commissioned carved monuments covered with dates, victories, family histories, and ceremonies. Astronomers tracked the movements of Venus, the Moon, and the Sun with extraordinary precision. Scribes recorded dynastic events in a writing system so complex that modern scholars spent generations learning how to read it again. But there was no single Maya empire that matters. The Maya world was a patchwork of competing city-states. Each had its own king, its own dynasty, its own allies, enemies, tribute demands, sacred places, and political ambitions. A powerful city might dominate its neighbours for a generation or two, capturing rulers and demanding loyalty. Then an alliance would shift, a rival dynasty would rise, and the balance would change again. For centuries this system produced art, trade, monumental building and scientific knowledge. It also produced constant pressure. Maya inscriptions do not describe a peaceful civilization suddenly struck by an outside force. They describe warfare, captured nobles, burned settlements, defeated kings. Political humiliation turned into stone monuments for everyone to see. By the late 8th and 9th centuries, conflict seems to have intensified in many parts of the southern lowlands. Cities built fortifications, populations moved toward defensible locations. Some rulers who had once raised monuments every few years stopped doing so. The last known dates carved on stone stelae become fewer and fewer. In some places, the royal courts appear to have lost the wealth, authority, or stability needed to continue the rituals that had defined classic Maya kingship. And then there was the climate. The Maya depended heavily on seasonal rainfall. Much of the lowland region had no great rivers flowing through its major urban centres. People collected rainwater in reservoirs, managed wetlands, cultivated maize, beans, squash, cacao and many other crops, and learned to live with the annual rhythm of wet and dry seasons. But evidence from lake sediments, cave formations and other climate records suggests that parts of the Maya region experienced repeated droughts during the centuries of political decline. Not necessarily one endless drought that destroyed everything. More likely, a series of dry intervals arriving in a world already crowded, divided, and under strain. A city can survive one poor rainy season. It can use stored food. It can draw on political alliances. It can ask surrounding communities for help. But several bad seasons change the calculation. Reservoirs fall. Crops fail. Food prices rise. Hungry people become angry people. Kings who claim to communicate with gods are expected to make the rains return, or at least provide grain when the rains do not come. If they cannot, their sacred authority begins to look less sacred. And in a landscape divided among rival city-states, a hungry neighbour may not offer help. It may see an opportunity. Environmental pressure may have made this worse. Growing cities required timber for building, fuel, plaster production and agriculture. Farmers expanded fields and intensified cultivation. In some regions, forest clearance and soil erosion may have reduced the ability of the land to recover from drought. But this too must be handled carefully. The Maya were not simply reckless people cutting down every tree around them. They used terraces, raised fields, water management systems, forest gardens, and many other methods that showed deep ecological knowledge. The problem was not ignorance. The problem may have been scale. A system that works well for a modest population can become much harder to maintain when cities grow larger. Elites demand more tribute, rival rulers wage more wars, and climate becomes less predictable. This is where the different causes begin to connect. Drought reduces harvests. Reduced harvests weaken rulers. Weak rulers face rebellions and invasions. Warfare disrupts farming and trade. Disrupted trade makes shortages worse. Elite families compete for shrinking resources. People abandon vulnerable settlements and move toward places that seem safer, wetter, or more politically stable. No single cause has to explain everything, because none of these pressures operated alone. By around 900 CE, many major centres in the southern lowlands had experienced severe population decline. Royal dynasties ended, monument building stopped, buildings were no longer maintained. Forest gradually reclaimed plazas where thousands had once gathered for ceremonies, markets, and political spectacles. But this was not the end of the Maya. Communities remained in the region. Families continued farming. Languages continued to be spoken. Religious traditions changed, adapted, and endured. People moved north into areas of the Yucatan Peninsula. where new centers, including Chichen Itza and later Mayapan, became important powers. Maya societies also continued in the highlands of Guatemala and southern Mexico. When the Spanish arrived many centuries later, they encountered Maya kingdoms, Maya merchants, Maya farmers, Maya scribes and Maya communities with long memories of their own histories. And they are still there. Today, millions of Maya people live across Mexico and Central America. They speak dozens of Maya languages. They maintain cultural traditions while participating in modern cities, schools, economies, governments, and political movements. The descendants of the people who built Tikal and Palenque were never swallowed by the forest. Their political order changed. Some cities declined. Dynasties fell. Populations moved. But a civilization is not only its tallest pyramids or its royal inscriptions. It is also the people who adapt after the monuments stop being built. The Maya case makes the word collapse feel less certain. From the viewpoint of a king watching his capital empty, the world may have seemed to be ending. From the viewpoint of a farming family relocating to a better watered valley, it may have been a terrible disruption, but not the end of life. From the viewpoint of their descendants, it was one chapter in a history that never truly stopped. And that is the danger of one-cause stories. They turn history into a countdown. One drought, one invasion, one disaster, and civilization is gone. The real pattern is usually more complicated. Societies weaken through interacting pressures. They fracture unevenly. Some places fail while others endure. And even when states collapse, people often carry knowledge, language, memory and hope into whatever comes next. Rome gives us an even larger version of the same lesson. When people say the Roman Empire collapsed, they often picture a single date. 476 CE. A young emperor in Italy, Romulus Augustulus, is removed from power by a military commander named Odoacer. The imperial insignia are sent east to Constantinople. And according to the neat version of the story, ancient Rome falls. The lights go out. The Middle Ages begin. It is a satisfying ending. History rarely provides satisfying endings. By 476, the city of Rome had already been sacked more than once. The Western Empire had been divided, reunited, divided again, and governed from cities far from Rome itself. Armies were increasingly commanded by men with Germanic backgrounds. Provinces that had once answered to Roman officials were ruled by local kings, generals, bishops, and powerful landowners. And in the eastern Mediterranean, the Roman Empire continued for almost another 1,000 years. The people of Constantinople did not think Rome had ended in 476. They called themselves Romans. Their emperors called themselves Roman emperors. Their laws, armies, taxes, ceremonies and administrators carried on the imperial tradition until Constantinople fell to the Ottomans in 1453. So what exactly fell? Not Rome all at once. What changed was the western half of an enormous political system, a system that had stretched from Britain to Egypt, from Spain to Syria, and depended on a complicated flow of taxes, grain, soldiers, officials, ships, roads, and information. For centuries, Rome had made that system work remarkably well. Not peacefully, not fairly. Roman power rested on conquest, slavery, taxation, and overwhelming military force. But it also created long-distance trade networks, paved roads, common laws, large cities, and a monetary economy that connected millions of people. A farmer in North Africa could grow grain that fed people in Italy. Potters in Gaul could sell tableware hundreds of miles away. Merchants carried wine, olive oil, metals, textiles, spices and ceramics across the Mediterranean. Soldiers stationed on the Rhine frontier received wages minted from silver gathered elsewhere in the empire. It was an interlocking world, and interlocking worlds can be powerful. They can also become fragile when too many parts begin failing at once. The strain had been building for generations. During the 3rd century, Rome faced civil wars, inflation, invasions, and rapid changes of emperor. Between 235 and 284 CE, emperors rose and fell with astonishing speed. Some were murdered by their own soldiers. Others died fighting rivals or foreign enemies. In a political system where an army could make an emperor, every successful general became a possible threat. The empire survived that crisis. Emperors such as Diocletian and Constantine reorganized it. They divided responsibilities among multiple rulers, expanded the bureaucracy, reformed taxation, and built new administrative centers. But survival came with a cost. Government became heavier. Taxes became more demanding. The army grew more expensive. Local communities that had once handled much of their own business found themselves more closely tied to imperial officials and imperial needs. Then came the military pressure along the frontiers. For a long time, Rome had managed its borders through a mixture of forts, diplomacy, trade, and carefully controlled migration. People from beyond the frontier entered the empire all the time. They served in Roman armies, traded in Roman markets, settled on Roman land, and adopted Roman customs. The problem was not simply that outsiders arrived. The problem was that in the late 4th and 5th centuries, large groups arrived under conditions Rome could no longer control easily. The movement of the Huns across the Eurasian steppe put pressure on Gothic peoples living north of the Danube. In 376, many Goths asked to enter Roman territory. Roman officials allowed them across, then exploited and mistreated them. Food was withheld, families were abused, a population seeking refuge became an armed enemy. 2 years later, at the Battle of Adrianople, a Gothic army destroyed a Roman force and killed the Emperor Valens. It was not the end of Rome, but it revealed something frightening. The empire still had armies, it still had money, it still had cities and laws and emperors. Yet it could no longer assume that every crisis at the frontier could be contained. Over the next century, Goths, Vandals, Suebi, Burgundians, Franks, and others established kingdoms inside former Roman provinces. Some fought Rome, some served Rome. Some did both, sometimes within the same generation. This was not a simple invasion story in which one civilization replaced another. Many of these rulers wanted Roman titles. They used Roman tax systems, Roman laws, Roman officials, and Roman military traditions. They minted coins in Roman styles. They governed populations that remained overwhelmingly Roman in language, religion, and daily custom. But each lost province meant fewer taxes for the Western imperial government. Fewer taxes meant fewer soldiers. Fewer soldiers meant less ability to defend the remaining provinces. And each new defeat made the next one more likely. This is how systems can unravel, not with one giant explosion, but with a chain of smaller failures. Disease may have added another layer of pressure. The Roman world had already endured the Antonine plague in the 2nd century, probably a devastating epidemic of smallpox or measles. Later, in the 6th century, the plague of Justinian spread through the Mediterranean world, reaching both eastern and western regions. We should be careful here. Disease did not single-handedly destroy Rome. Ancient sources can be dramatic, and the exact death tolls remain uncertain. But epidemics can weaken societies in ways that are difficult to measure from a distance. They remove workers, soldiers, taxpayers, parents, artisans, and officials. They interrupt trade. They create fear. They make an already stressed government less capable of responding to the next emergency. and ordinary life did not change everywhere at the same speed. In some Western cities, public baths closed, aqueducts fell into disrepair, civic buildings were abandoned, and long-distance trade declined. Fine pottery that had once travelled widely became rarer. Coinage became less common in daily exchange. Literacy narrowed into smaller circles. But in other places, towns continued. Farms continued. Churches became new centres of authority. Bishops took on roles once handled by imperial officials. Roman law survived in altered forms. Latin survived, changing slowly into the languages that would become French, Spanish, Italian, Portuguese, and Romanian. A person living in Italy in 450 might have felt the empire weakening. A person living there in 500 might still have spoken Latin, prayed in a Roman church, used Roman legal ideas, and remembered an emperor in Constantinople. The institutions were changing before everyone could see that they had changed. That is the strange thing about long decline. It can be invisible while you're living through it. There is no morning when every road suddenly cracks, every market closes, and every memory disappears. There are just more repairs postponed, more taxes that cannot be collected, more soldiers who are not paid, more officials who answer to local strongmen instead of distant capitals, more families deciding that a fortified hilltop feels safer than an open town. For some people, the end of Western imperial rule meant violence, dispossession, and real loss. For others, especially local elites who found ways to work with new rulers, it could mean continuity with a different name attached to power. That is very different from the sudden, planet-wide collapse imagined by periodic catastrophe theories. Rome did not fall because a cosmic clock reached zero. It changed through political division, economic strain, military competition, migration, environmental uncertainty, disease, and the difficult mathematics of holding together a vast empire. Its transformation took centuries, and after the Western Empire disappeared, the people did not disappear with it. They rebuilt lives inside new kingdoms. They preserved fragments of old institutions. They invented new ones. They carried Rome forward, not as a single unbroken state, but as laws, languages, roads, churches, memories, and dreams of order in a fractured world. And that brings us to the present. Our world is more connected than Rome ever was. A container ship leaving East Asia can carry electronic components, medicines, machine parts, clothing, and household goods to ports thousands of miles away. Grain grown in one region can feed cities on another continent. Natural gas, oil, coal, uranium, wind turbines, solar panels, fertilizer, computer chips, and financial loans all move through systems so large and complicated that no single person fully understands them. That sounds alarming. It is also one of the great achievements of human history. Modern global networks allow places hit by drought to import food. They allow hospitals to receive medicines made far away. They allow warnings about storms, earthquakes, disease outbreaks, and volcanic eruptions to travel around the world in seconds. A failed harvest in one country does not automatically mean famine there, because food can come from somewhere else. Complexity gives us options, but it also creates dependencies. A city may have enough money to buy food, but no food if ports close. Trucks cannot get fuel, or a distant war interrupts shipping routes. A factory may have workers, buildings, and customers, but still stop producing because one tiny specialized component has not arrived from another country. A hospital may have skilled doctors and advanced equipment, but face danger if electricity, clean water, medicine, communications, or supply deliveries fail at the same time. Modern civilization is not one machine with one switch. It is more like an enormous web. Food systems depend on fuel. Fuel systems depend on infrastructure. Infrastructure depends on spare parts, trained workers, financing, computer networks, and political stability. Finance depends on confidence. Communication depends on electricity, satellites, cables, and data centers. And nearly all of it depends, in one way or another, on a living planet that provides stable climate patterns, fertile soil, fresh water, pollinating insects, fisheries, forests, and predictable seasons. Most of the time, this web is astonishingly efficient. Efficiency means fewer warehouses, faster deliveries, lower costs, and less waste sitting unused in storage. A company does not need to keep years of spare parts in a warehouse if a supplier can send them exactly when needed. A supermarket does not need to store months of food if trucks arrive every day. But efficiency often means less slack, and slack is what saves you when something goes wrong. A little extra water in a reservoir, a second supplier, for a crucial part, emergency grain reserves, a backup power system, well-maintained public health laboratories, savings in a family account, trust between neighbours. These can seem expensive or unnecessary during calm years. Then a crisis arrives, and they become the difference between disruption and disaster. The risks facing the modern world are not mysterious prophecies from a 12,000-year clock. They are visible, studied, and in many cases already underway. Climate change is one of them. It does not mean that every place becomes equally hot, dry, wet, or dangerous. Climate is complicated, but a warmer atmosphere can intensify heat waves, shift rainfall patterns, raise sea levels, worsen some droughts and floods, and increase stress on crops, water supplies, coastlines, and ecosystems. A heat wave can damage harvests. A damaged harvest can raise food prices. Higher prices can deepen political tension in countries already struggling with debt, inequality, or conflict. One problem becomes several. Pandemics offer another example. Modern medicine can identify pathogens, sequence genomes, develop vaccines, and share data at speeds unimaginable in earlier centuries. That is an extraordinary advantage. But global travel also allows a new disease to move rapidly between cities and continents. A health emergency can become an economic emergency when workers are sick, schools close, hospitals fill, and supply chains slow down. War can create similar cascades. Fighting in one region can disrupt exports of grain, fertilizer, energy, metals, or computer components. Cyber disruption can interfere with banking, transport, communications, hospitals and power grids without a single soldier crossing a border. Ecological stress can reduce fisheries, degrade soil, drain aquifers, and shrink the margins on which millions of people depend. None of these dangers operates alone. A drought does not automatically cause conflict. A disease outbreak does not automatically cause state failure. A cyber attack does not automatically bring down a country. History warns us against that kind of simple story. But overlapping shocks can make each other worse. A government dealing with flood damage may have fewer resources for public health. A society divided by political distrust may struggle to respond to a pandemic. A nation dependent on imported fuel may be more vulnerable during war. A farming region already stressed by heat may be less able to absorb a sudden fertilizer shortage. This is not inevitability. It is vulnerability, and unlike the people living through the Bronze Age collapse, the Maya droughts, or the slow unmaking of Western Rome, we possess tools they could barely imagine. We monitor the atmosphere from satellites. We track storms across oceans. We study ice sheets, ocean temperatures, crop diseases, viruses, earthquakes, and volcanic gases. We have weather forecasts, emergency communications, global scientific institutions, public health systems, international aid networks, and vast stores of recorded knowledge. We can see many dangers coming. The harder question is whether we will act before they become emergencies. Knowledge alone does not create resilience. Warnings must be believed. Infrastructure must be maintained. Institutions must be trusted. Resources must be shared before scarcity turns every neighbour into a competitor. Modern civilization is neither invincible nor doomed. It is powerful because it is connected. It is fragile for exactly the same reason. So, are we actually overdue? Overdue for what, exactly? This is the question hidden inside the 12,000-year claim. It sounds precise. A great disaster happened roughly 12,000 years ago. Civilization has now lasted roughly 12,000 years. Therefore, another great disaster must be close. But the logic changes the moment we look more carefully at the dates. The end of the last ice age was not a single event that happened on a single morning everywhere on Earth. It was a long planetary transition with warming, cooling, melting ice sheets, shifting rainfall, rising seas, changing forests, and migrating animals. The Younger Dryas cold reversal began around 12,900 years ago. It ended around 11,700 years ago. The world that followed was warmer overall, but it was still changing. Already the supposed clock has a problem. Is the countdown meant to begin at the start of the Younger Dryas? Its end? The first major pulse of meltwater? The point when sea levels rose enough to drown a particular coastline? Different choices produce different dates, and then there is civilization itself. If by civilization we mean permanent cities, writing states, large bureaucracies and formal systems of taxation, then civilization is not 12,000 years old. The first villages and ritual centres emerged in different places at different times after the Ice Age. Farming developed gradually. Towns expanded gradually. Writing appeared much later, in Mesopotamia and Egypt, a little more than 5,000 years ago. The first true urban civilizations are separated from the end of the Ice Age by thousands of years. Göbekli Tepe, remarkable as it is, was not a city in the later sense. It had no known writing system, no palaces, no bureaucracy that we can identify, no giant population living permanently behind walls. It tells us that early communities could organize labour, build monuments, and create complex ritual worlds far earlier than scholars once expected. That is extraordinary. But it does not mean that Sumer, Egypt, the Indus cities, Shang China, the Maya kingdoms, Rome, and the modern industrial world all began on the same day, triggered by the same climatic turning point. Human history is not one uninterrupted civilization stretching backward to 10,000 BCE. It is a vast collection of different societies, beginning in different places, developing different technologies, rising, adapting, transforming, fragmenting, and sometimes disappearing. Some were linked, many were not. A drought that struck one river valley might mean hardship there, an opportunity somewhere else. A collapsed kingdom did not erase humanity. It did not even necessarily erase the people who had lived under that kingdom. Often those people remained, changed their language, moved their homes, rebuilt their networks, and carried on. The 12,000-year reset claim turns this complicated record into a neat repeating pattern. And neat patterns are seductive. They give chaos a shape. They make the future feel knowable. If history runs on a schedule, then perhaps we can find the schedule, mark the next date on a calendar, and prepare ourselves for the appointed hour. But the evidence does not show a reliable 12,000-year cycle of civilization-ending catastrophe. Earth does have rhythms. The planet's orbit changes over long periods. Ice sheets advance and retreat. Oceans shift heat around the globe. Volcanoes erupt. Earthquakes happen. Rivers flood. Droughts return. Solar activity varies. None of this means that all those processes combine every 12,000 years to erase human societies. A cycle is not established because two dramatic events can be placed roughly the same distance apart. To demonstrate a real cycle, scientists would need repeated events, accurately dated, with a consistent interval and a plausible physical mechanism connecting them. That standard has not been met. What often happens instead is more subtle. A real scientific uncertainty enters the story. Perhaps archaeologists do not know exactly what lies beneath a drowned coastline. Perhaps paleoclimate records show a rapid ancient shift. Perhaps an impact hypothesis remains debated. Perhaps an ancient flood story resembles another flood story from far away. Then uncertainty becomes possibility. Possibility becomes suggestion. Suggestion becomes a documentary voice saying, "Could this be evidence?" And after enough repetitions, the question mark quietly disappears. Soon, a speculative idea is presented as a suppressed fact. A broad date range becomes an exact date. A local disaster becomes a global reset. And a warning that ancient climate was unstable becomes a prediction that modern civilization is living on borrowed time. This does not mean the future is safe simply because the countdown is false. It means we should be more careful about what we fear. The useful question is not, when does the 12,000-year clock strike midnight? The useful question is, which dangers do we already understand well enough to reduce? We know that a warming climate can stress food, water, coastlines, and public health. We know that pandemics can spread through connected populations. We know that nuclear weapons, war, financial shocks, cyber attacks, soil loss, ecosystem decline, and fragile supply chains can create cascading failures. We know that rare natural hazards, including major volcanic eruptions and asteroid impacts, are real even if they do not follow a convenient schedule. These are not prophecies. They are risks, and risks can be studied. They can be measured, reduced, insured against, prepared for, and sometimes avoided altogether. The absence of a cosmic deadline is not a reason for complacency. It is an invitation to pay attention to the real world. And once we ask that question, history gives us something more useful than a countdown. It gives us clues about resilience, not a magic shield. Not a guarantee that nobody suffers, no city burns, no harvest fails, and no way of life has to change. History does not offer that kind of comfort. Resilience means something quieter and more realistic. It means that when a shock arrives, a society has enough options, enough stored knowledge, enough trust, and enough flexibility to keep going. Maybe not exactly as before, but going. Think about the difference between a single rope and a net. A rope can be very strong, but cut it in one place, and everything hanging from it falls. A net is made of many smaller threads. Some can break without destroying the whole structure. Resilient societies tend to work more like nets. They have multiple ways to feed people, move goods, organize help, preserve knowledge, and make decisions. The first of these is diversity. A community that depends on one crop, one river, one trade route, one source of energy, or one small group of rulers can work beautifully in ordinary times. It may even be extremely efficient, but efficiency and resilience are not always the same thing. A field planted with only one crop can produce enormous harvests when conditions are right. Then a new pest arrives, the rains fail, or the temperature shifts by a few degrees, and the entire system is exposed at once. Farmers have understood this for thousands of years. They mixed crops. They planted different varieties. They kept livestock as well as grain. They gathered wild foods even after farming became common. They stored seeds from plants that did well in dry years, wet years, cold years, and strange years. This was not primitive caution. It was practical intelligence. In the Andes, communities cultivated crops at different elevations, where weather could vary dramatically over only a few miles. If frost damaged one field, another might survive lower down. In parts of Africa, farmers combined grains, legumes, roots, and herding in ways that spread risk across different seasons. Across the Pacific Island, societies developed careful systems for managing breadfruit, taro, fish, and fresh water. No system was invulnerable, but many were designed around the basic understanding that nature does not always repeat itself. The same principle applies beyond food. A city supplied by one road is vulnerable. A kingdom whose wealth depends entirely on one luxury export is vulnerable. A population concentrated in one floodplain, with nowhere else to go, is vulnerable. The Bronze Age world was rich, sophisticated, and connected, but many of its great states relied on long chains of trade for metals, timber, grain, skilled labour, and prestige goods. When war, drought, migration, internal rebellion, and disruption overlapped, those connections became channels for crisis as well as prosperity. Connection can make societies stronger. It can also allow trouble to travel. That is why redundancy matters. Redundancy sounds like an engineer's word, and perhaps it is. It means having more than one of something important. More than one grain store, more than one water source, more than one route across the mountains, more than one person who knows how to repair a tool, deliver a child, navigate by the stars, or settle a dispute. Modern systems often remove redundancy because it seems wasteful. Why keep extra supplies when deliveries arrive every day? Why maintain spare capacity when every machine can be used at maximum efficiency? Why preserve an old local practice when a centralized system appears faster and cheaper? And in stable times, those choices can seem sensible. But stable times are exactly when resilience is built. You do not begin digging a well after the river has dried. You do not begin learning which wild plants are edible after the harvest has failed. You do not begin building trust with your neighbours after the roads are blocked and the power is out. This brings us to local knowledge. Every landscape has details that cannot be fully captured on a distant map. Which stream runs longest in a dry season? Which hillside floods first? Which soil holds water? Which old channel becomes dangerous after heavy rain? Which trees survive salt spray? Which grain ripens before the hottest part of summer? Which path remains passable when the main road disappears beneath mud? For generations, people stored this knowledge in habit, story, ceremony, language, and memory. Sometimes it was written down, often it was not. It was carried by farmers, fishers, herders, healers, builders, and elders who had watched the same land through many seasons. That does not mean every traditional practice was wise, or that old knowledge should never be questioned. Some customs can become rigid, some were shaped for conditions that no longer exist. But dismissing local knowledge simply because it is old can be a serious mistake. The people closest to a changing environment are often the first to notice what is changing. Past communities survived not by remaining frozen in tradition, but by adapting tradition to new conditions. When rainfall changed, people changed crops. When rivers shifted, they moved fields or settlements. When trade routes became dangerous, merchants found new routes, travelled in convoys, or exchanged different goods. When old political systems could no longer protect people, local councils, religious institutions, village networks, and kin groups often took on new roles. After the Western Roman Empire fragmented, for example, life did not simply switch off across Europe. Cities declined in many regions. Long-distance trade narrowed. State institutions weakened. There was violence, disease, and hardship. But people also adapted. Agricultural communities continued. New kingdoms formed. Monasteries and religious centres preserved some texts and skills. Local identities became more important. Old roads carried new kinds of movement. The world changed shape. that is not the same as saying collapse was harmless. It was not a resilient society can still lose population, wealth, buildings, languages, political freedoms and irreplaceable works of art. People living through a collapse do not experience it as an interesting transition in a history book. They experience hunger, uncertainty, grief, and the terrifying feeling that the familiar rules no longer work. Resilience is not preventing every loss. It is reducing unnecessary loss. It is making sure that one failure does not become 10. It is giving people room to adapt before desperation turns every problem into a catastrophe. And this is where trust becomes as important as grain. During a crisis, people need information they believe. They need institutions that can act without treating everyone as an enemy. They need neighbours, family networks, mutual aid groups, medical workers, local leaders and strangers willing to cooperate. A reservoir matters. So does the ability to share its water fairly. A food store matters. So does confidence that it will not be seized by the powerful while everyone else is left waiting. Trust cannot be manufactured at the last minute. It grows slowly through competence, fairness, shared obligations, and the ordinary experience of people helping one another without being forced. Societies with deep inequalities can appear powerful for a long time. But if most people believe that the system exists only for a small elite, then a shock can expose fractures that were already there. Adaptable institutions matter for the same reason. Rules are necessary. Governments, markets, laws, and public services all provide structure. But systems that cannot revise their assumptions become brittle. If every decision must move through one distant centre, local emergencies may outrun the response. If leaders cannot admit mistakes, warnings go unheard. If a society treats change as failure, it may cling to an old solution long after the world has changed around it. The strongest institutions are not those that never bend. They are the ones that can bend without breaking, and beneath all of this lies memory. Not only memory stored in books, archives and databases, though those matter enormously, also memory stored in stories, rituals, songs, practical skills and community habits. Flood markers carved into stone, oral histories about past fires, seed collections, maps of old wells, records of epidemics, recipes that make scarce food go further, the knowledge of how to repair, reuse, preserve and share. Civilization is not just buildings and machines, it is accumulated learning. Every generation inherits a library, whether it recognizes it or not. Some of that library is held in universities and museums. Some is held in grandparents' hands, some is embedded in languages that may have only a few speakers left. When knowledge disappears, a society loses options. When it is preserved and shared widely, people have more ways to respond when familiar systems fail. So the lesson of history is not that we should wait nervously for an ancient clock to strike. It is that the future remains open. The past shows us sudden climate shifts, drowned coastlines, failing kingdoms, abandoned cities, pandemics, migrations and wars. It also shows us farmers trying new seeds, families rebuilding after floods, traders opening new paths, communities taking in strangers, and people carrying fragments of knowledge through dark and uncertain centuries. There is no evidence that civilization is scheduled for destruction every 12,000 years. But there is abundant evidence that societies survive best when they prepare for change, share burdens, protect knowledge, and refuse to place all their hopes on a single fragile system. History does not run on a countdown. It runs through choices, conditions, accidents, and human beings learning, sometimes painfully, how to endure. And that may be the most important place to end, not with a date circled on a calendar, not with the claim that somewhere hidden beneath the ruins of old cities and the ice at the poles, there is a clock counting down to the next great collapse. Because the evidence does show something real. It shows that Earth's climate can change suddenly. It shows that seas can rise over landscapes where people once lived. It shows droughts that lasted for generations, rivers that shifted course, harvests that failed, and volcanic eruptions that darkened skies far from the mountain that produced them. It shows villages abandoned, trade networks broken, palaces burned, languages lost, whole ways of life transformed so completely that later people could barely imagine what came before. The Younger Dryas was real, the flooding of ancient coastlines was real. The 8.2 kiloyear event was real. The struggles of Bronze Age kingdoms, Maya cities, Roman provinces, and countless communities whose names were never written down were real. Human history is full of upheaval, but upheaval is not the same thing as a schedule. There is no established evidence showing that civilization collapses precisely every 12,000 years. No reliable geological mechanism that rings like a bell on that interval. No unbroken archaeological pattern in which advanced societies rise, vanish, and reset at exactly the same point in a cosmic cycle. That does not mean we know everything. Far from it. Much of the human past is still underwater. Much of it lies beneath modern cities, forests, deserts, farms, and roads. Many ancient settlements were built near rivers and coasts, exactly the places most changed by rising seas and shifting sediments. Archaeologists will certainly make discoveries that change parts of this story. They always do. A stone tool found in the wrong place can move a migration route by thousands of years. A buried village can reveal a forgotten adaptation. A new ice core, pollen record, or genetic study can show that a climate event was more complex than anyone realized. That uncertainty is not a weakness. It is how knowledge works. But uncertainty is not proof of every possibility. A gap in the record is not automatically a lost global civilization. A mystery is not automatically an answer. The responsible response to what we do not know is curiosity, patience, and the willingness to let evidence lead. Sometimes the past is stranger than we expected, and sometimes it is simpler. The people who survived climate shifts and collapsing states were not always rescued by secret knowledge or impossible technology. More often they endured through practical things. Moving when they had to, sharing food, changing crops, maintaining kinship ties, remembering where water could be found, carrying seeds, stories, skills, and children into whatever came next. Civilizations can fall, but humanity is not a civilization. It is not one city, one empire, one supply chain, or one idea of progress. It is a vast, stubborn network of people, spread across landscapes and generations, always losing something, always preserving something, always building again from what remains. A burned palace is not the end of everyone who lived beneath its king. An abandoned city is not the end of the farmers beyond its walls. A drowned coast is not the end of the people who remembered the shore. History, when you look closely enough, is not only a record of endings. It is a record of continuations, of survivors who became ancestors, of broken worlds that became the raw material for new ones, of knowledge carried forward in hands and voices, sometimes quietly, sometimes across enormous distances. So perhaps we are not overdue for a predetermined collapse. Perhaps we are simply living as every generation has lived, in a world full of risk, change, and choices. And perhaps the useful question is not, when does the clock run out? It is, what do we choose to preserve while there is still time? If you enjoyed this journey through deep time, forgotten coastlines, collapsing kingdoms, and the stories we tell about the end of the world, please like the video, subscribe to the channel, and leave a comment telling us where you are listening from tonight. And if you would like to support the channel in the best possible way, listen on Spotify through the link in the description. For now, rest easy. History does not run on a countdown. It runs on memory, adaptation, loss, and the quiet human determination to begin again.